I hope I'm audible to all of you.
Sir,
I
you are
hope
audible.
I'm audible, right?
Yes, yes, sir.
Yeah.
We will start exact 6 o'clock.
Perfect. I'm ready.
Yeah. Very good morning, good evening to all of you. A very warm welcome in the third session of AICT approved ATAL FDP on AI powered urban futures, advancing sustainability in smart cities. I welcome to Professor Agnivesh sir for his exposition. Uh, Professor Agnivesh is the assistant professor in the Department of Civil Engineering at IIT Varanasi. With a PhD in transportation engineering, Dr. Agnivesh worked as a postdoctoral researcher in the Freight Mobility Research Institute, University of Memphis in past. After joining IIT BHU, he had led multiple projects on mul- multimodal transportation planning challenges, including a recent project under National Mission on Interdisciplinary Cyber Physical System, focusing on multimodal transit integration and route expansion strategies under fairness constraints. The technology transfer under this completed project is collated in a dashboard currently used in Varanasi by Uttar Pradesh State Transport Corporation for transit crowding and occupancy prediction. Furthermore, Dr. Agnivesh is leading a project currently by ICSSR Vikshit Bharat scheme focusing electric bike sharing network development as a last mile complement for public transport systems. Other ongoing projects include a DST project focusing on freight models shift to Inland Waterways and the Ministry of Road Transport and Highways, MORTH, project developing nationwide freight forecasting models for highways as a part of IRC 106 upgradation. So, Mike is over to you, sir.
Thank you. Thank you, Professor Kiran. It's a great pleasure to be part of this faculty development program. So I think these kind of programs are great. I think the topic is also very relevant for today's times, specifically talking about AI-enabled futures. I
Yes,
think we are living in a era where a lot of interest is there on generative AI and large language models. So I'm very happy to be a part of the session. Specifically, I'm talking about my core area of urban mobility. So let me share my screen. I hope I'm clearly audible and I'll just share my screen. Right?
exactly. You are audible.
Okay, perfect. I'll just share my screen.
Yeah.
My screen is visible to all of you.
Yes, sir.
My screen is visible, right?
Yes,
It's good.
sir.
Great. So I know that there are a lot of wide range of participants attending the session. So specifically, I'm going to be talking about AI in traffic and transportation systems. Many of you might be civil engineers. Some of you might be from other departments, but with an interest in these kind of transportation systems. So in the case of urban mobility, specifically when we talk about a transportation perspective, the idea is that how do we plan better for moving people and goods? So all of us know that it's rather straightforward when we talk about planning transportation systems, because traditionally we used to focus on the construction part, on the pavement engineering part. But I think after developing some level of infrastructure systems, the question comes, how do you plan for it in a more effective manner, more economic manner, and how do you leverage data for developing these systems? So with the power of data that is rolling across the country, there is a lot of scope for using artificial intelligence based models. So let me give you kind of an overview of what we are going to discuss about. In today's session, I'll be talking about a couple of core concepts, what we can use AI for traffic and transportation system management. And specifically, I will give you some case studies that we have explored in the city of Varanasi and some other cities in India, and how we can use these knowledge for the way forward. Now, let me give you a background of it. Now, specifically, when we talk about urban mobility, we know that most of our cities have become increasingly congested. And when we talk about sustainable mobility, a mobility that has the least negative externalities on the surroundings, that is like a significant factor for all the smart cities. Now, we know that under the Ministry of Housing and Urban Affairs, we have more than 100 smart cities being implemented in the country. Now, each of these smart cities, most of you might be aware, we already have traffic and traffic management centers. We have these ICCCs, right? All these command centers are particularly useful for understanding different kinds of traffic in a city. The idea is to improve the quality of life, reduce the carbon emissions, and enhance the overall system efficiency. So, what is the role of a transportation engineering and planning here? The idea is that can we use the increasing power of real-time data for developing solutions and real-time decisions, which are traditionally done by humans, and can we replace it by software programs? It's as simple as that. So when we talk about generative artificial intelligence, the idea is that we are trying to make some kind of decision making which can be driven by a computer program. And that computer program removes the need for human interventions. And it will help for optimizing the traffic systems to make it more sustainable, efficient, and more livable urban environment. So there are a lot of case studies that I can give you here. Some specific examples also I'll be discussing as we go forward. So the entire presentation that I'm going to give today, I'm specifically going to talk about four thrust areas. One, how AI can be used for traffic management. And within that, we have many case studies. Then how AI can be used for public transportation systems, how AI can be used for sustainable mobility solutions, and how AI can be used for environmental impact reductions. Because let us face it, transportation by default is going to have some effect on the environment, whether it is in the way we are driving our fossil fuel driven cars, whether we are talking about different types of emissions that are coming from our movement, it is going to have some impact. So can we try to reduce its impact on the environment? So let us try to go through it one by one. When you talk about AI driven traffic management, there are a couple of specific sub examples that I want to give. So, one, we are going to be talking about real time traffic prediction and optimization. I will give you specific case studies on that. How we can talk about demand driven, density, informed, adaptive traffic signals. Can we talk about real time incident detection and management? And for example, currently I am in the city of Prayagraj, where Kumbh Mela is set to happen in a matter of a week. So many AI-driven cameras are currently laid out in the city so that we can have real-time incident management. So I will give you a couple of examples on that. Now, specifically on AI and public transportation systems, this is a concept that recently got a lot of attention. How we can develop new public transportation systems, which whose network design is driven by the transportation demand. So instead of having some fixed transit in a particular city, it can be bus-based transit, it can be a metro network. The idea is that how do we use a more multimodal integrated transport system which are driven by the demand that we can get from the real time. How do we develop predictive maintenance systems for the transportation systems? Can we talk about smart ticketing and fare systems? Again, which will help us to have more real time data. So that is the application for the second area, AI in public transportation systems. And the third area is how we can use AI for sustainable mobility solutions. Now, there is a lot of uptake of electric vehicles in the country. Now, how do we use the data that we can get from the public domain for the developing the infrastructure for EV movement? So specifically, how do we develop EV charging stations with the publicly available data? How do we develop shared mobility systems? For example, in the city of Varanasi, currently we are developing a ropeway system where ropeway is considered as a potential solution for tourist movement towards the temple. So we'll have an urban ropeway, which are basically cable cars moving on a fixed system, and we'll have bus transit, and potentially we have this informal public transport in the sense of we have auto rickshaws and e-rickshaws. How do we have a multimodal shared mobility system which can be used for large scale movement of people? And how do we talk about integration of data from these multiple systems? That's again something of interest for the sustainable mobility solutions. And finally, how do we talk about AI and environmental impact reduction? It can be in terms of emission monitoring, because now the state of the art is that can we measure emission at very local levels? Can we have these sensors in different parts of the city where we can measure, and I'm talking about transportation related air pollution measures, trap measures, how we can have this road emission inventory throughout the city, and can we talk about mitigation measures which are driven by the real time data? Can we talk about eco driving assistance where we can give some kind of guidance for the drivers to drive in a more sustainable manner, again based on the driving behavior that we are observing? And can we talk about some kind of mobility analytics for better urban planning? So this is kind of the background that I wanted to give on how we can use AI for traffic and transportation systems. We are not going to be focusing much on the development of AI systems part, because I still feel that there is a lot of focus need to be given on the actual change that we are keeping in the system. So we are going to give specific focus on the application side, how we can leverage the data. And all these case studies are not perfect examples, because so far we have challenges in the data as well. So what are the challenges that we are going to face, particularly in developing these AI driven solutions, and how do we overcome that? And we'll discuss some of them case by case. All right. So with that background, and let us start discussing about AI driven traffic management. So traffic management, the idea is that we have a lot of data coming from traffic sensors, cameras, GPS devices, and in all the smart cities that we have, at present, there are a lot of traffic cameras available, a lot of the CCTV cameras, which can capture real-time movement throughout the 24 hours and 365 days. And we also have, for example, many of these traffic sensors kept. It can be loop detectors. It can be some kind of GPS devices on multiple devices, such as the buses in a city. Can we use these diverse arrays of data to predict the traffic conditions beforehand and optimize the traffic light times? I will give you an example. So, for example, I'm talking about a entire city And I want to develop a system which predicts on a given day what will be the traffic flow, what will be the traffic density, and for example, what will be the speed characteristics, what will be the braking characteristics at different parts of the city, because we have such wealth of data from the past. And when we have this historical data, because there are wide array of models that we can develop, machine learning models that we can develop, and these models will be able to predict absolutely new values of these traffic parameters, which are not known to the program beforehand. So the idea of generative AI is that we are developing content which are not known to the program, which are real time based on some kind of independent variables. So this kind of predictions will help us to act beforehand. Suppose an accident has happened. How do we talk about the reduced delay to make sure that the evacuation plan, or I'm talking about the post-accident evacuation of the incident. How do we minimize that? So we can try to reduce the delay, we can try to minimize the fuel consumption, and we can also try to lower the emissions. When we know that at a particular time period, a particular stretch has higher density, we can try to adjust the traffic signal timing accordingly, which will adapt to the changing traffic pattern. And naturally, the cities will be able to dynamically respond to the fluctuating traffic volume. So the idea is that we'll have these machine learning algorithms built from the past data that we are collecting from these traffic sensors, and how that can be used for real-time decision making. Because there is no need of any human intervention here. That is why we are mentioning it as an application of generative AI. Because when we have these models calibrated with the wealth of data we have, for example, if you're talking about traffic cameras, we are talking about more than 100 TBs of storage, right? And we are collecting real-time parameters on the traffic speed, flow, density parameters. Can we use that for dynamic response for different incidents happening in cities? So this is one really interesting area of AI application with a lot of interest. So I would like to give you a case study on something that we are currently exploring in IIT BHU Varanasi under in one of my projects. So what we are trying to do here, can we use some kind of a guidebook? So this we are developing at the level of the country. So this is a project that is funded by the Ministry of Road Transport. So what we are trying to do is, can we use the wealth of data that we have spread across the country to develop some kind of forecasting models, specifically focusing on the freight demand? Okay, so why am I emphasizing on this particular thing? Because generally, when we do urban mobility planning, we always focus on the passenger volume, because ultimately 70 to 80% of the traffic is going to be the passenger traffic. But there is also a good amount of truck traffic in our cities, increasing particularly in the recent years because of the e-commerce. So when we talk about this in high heavy vehicles, which are tractor trailers or different type of heavy commercial vehicles, how do we develop guidelines? Because ultimately the transportation systems and the pavements are designed for heavy commercial vehicles because they are carrying the maximum load. So can we develop some kind of a guidebook, an AI-driven guidebook, which will help to estimate different kinds of traffic demand volumes on different parts of the country? And currently, whatever IRC code, the Indian Road Congress code that we have on these kind of predictions, it does not take care of the need for real-time predictions. So the objective is kind of complementing it in this background. And of course, the traditional models, which are not AI driven, are largely point driven. So we are collecting some data from different parts in the country, and we are trying to develop some models for those points. That's not the objective here. We are talking about the scale of a particular country. So individual modeling at the level of one particular establishment, because ultimately the freight demand is coming from shippers, carriers, and receivers in a system. So each of these establishments, if I am trying to capture, I'm talking about millions of establishments. And surveying each of them is again not going to be practically feasible. So what we are trying to do, we are trying to model them at the level of the corridors, at the level of the national highways, right? So these national highways are the main arteries connecting our country. And how can we use these models, these AI-driven models, for pavement design, whether we are using it for highway expansion planning, whether we are developing some kind of investment decisions, if I am setting up some kind of toll decisions, some cost benefit analysis, some environmental impact assessment, all these applications can be clearly be benefited when we have this kind of a model. So what do we do for the data? That is the first thing that we have to discuss. So what we tried to understand was that, can we use the toll plaza data, which is like the fast tag information that we get, for example, every time a vehicle crosses a particular toll plaza. All we need is, for example, the time of entry, the time of exit. We'll know the vehicle type. And when we get this kind of a data set, we can use that for a nationwide model, which will predict the spatio-temporal variation across different corridors. So we have used some kind of graph neural network models, some deep neural network models, and we are also using data on the vehicle registration in each and every part of the country. We are using some vein motion data that again we are able to collect from different parts of the country. So this entire gamut of data, what we can do with it is that it will capture the movement across the country as well. So what I'm showing you here is basically two frameworks. One is the data at the aggregate level, that means at the level of the highway corridors, and the other is the data at the disaggregate level. That means the data at the level of establishments. So we are tackling this problem at both levels. So at the aggregate level, you can see, for example, here, different toll plazas spread across the country, where our focus is corridor level movement. There are about 1,300 toll plazas. There are a lot of weighing motion stations, something we are focusing. At the disaggregate level, we are looking at each and every state. For example, we have already covered several cities in Kerala, in Telangana, in Rajasthan, we have covered Jaipur. We have covered many parts in the eastern India, in Odisha, in Jharkhand, West Bengal. We have also covered, for example, city of Hyderabad. We are trying to cover something in different cities of UP. So the idea is tackle both aggregate level and disaggregate level, because whenever we talk about AI-driven decision making, without data, we cannot really make any decisions. So the foundation of AI-driven systems is data. And we cannot complain about lack of data anymore, because there is a lot of passive data being collected in many public systems. So how do we leverage that? That's the bigger question. So currently what we are developing is we are trying to develop some kind of a dashboard where different types of traffic control groups are being selected, where we are trying to predict the movement by vehicle class. So each vehicle class in different sections of the road stretch can be predict, and looking at the toll plaza, looking at the highway stretch, can we predict the vehicle movement? So what is the benefit of a system like this? When we have a dashboard that is being developed right now, so these kind of dashboards can predict in future at a particular time period what is going to be the level of traffic in a particular highway. And these predictions can naturally help us to plan for the future highway expansion. It can help for the pavement design. There are a lot of applications that can be resulting from these kind of dashboards. So this is one great examples that I can tell you where we can use multiple types of predictions. I'm not going into too much of detail here because there are a wide range of applications that I want to kind of discuss here. The idea is that how do we use it for real-time traffic prediction? And you can see the example and the case study that I was just highlighting. The second case study, as I can show you here, under the real-time traffic optimization part, is 1B, something I'm noting as adaptive traffic signals. How AI can adjust the traffic signals based on the real-time parameters that we have on traffic flow. So let me give you a background, because I assume that not everybody in the participant may be familiar with the signal design or civil infrastructure systems. So let me give you a bit of a background. Typically, when we design traffic signals, we go for a fixed approach where we are selecting the different time periods for green time, red time, amber time, and we are specifying it for maybe 2 times in a day. And we are keeping that particular time period constant, at least during that morning peak and the afternoon peak. So essentially what we are telling is we are accepting that at some time there is going to be wasted green time. That means not everybody is going to use the green time given for a particular approach road. And at some point, there could be long queues in a particular signal. This is something you must have noticed when you're driving through many intersections, that you go to an intersection and you're just waiting there. You're just waiting there. There is no movement in the other approach road. And you're just waiting for the signal phase to change so that you can move, even though there is no vehicle moving at that point of time. So how can we overcome that? We can actually overcome that if we have an adaptive traffic light system, which predicts the traffic flow at every 1 minute interval. And using that traffic flow value, we are going to dynamically adjust the green and red light durations. So this will help to optimize the traffic flow. And this will also help to reduce the bottlenecks that we have in the many of our transportation systems. So this approach is particularly effective when we talk about very busy urban intersections. Because whenever we have a static signal, a fixed signal, that is going to be very inefficient in this kind of urban intersection. So I will give you one case study on it also, but let me give you a brief background on some technical terms. Because without explaining the fundamentals of it, I think explaining too much on the AI part won't be helpful to any of you. So the idea is that I'm giving an example of a intersection where multiple vehicles are coming and they are queuing up in a particular approach road. I can show you vehicle number 1, vehicle number 2, vehicle number 3, and up to vehicle number n. All these vehicles are coming and one by one they are queuing up in a particular approach road. So the fundamental idea that we are designing this intersection is for, we are measuring something called headway. And for example, the first vehicle that is coming to a particular intersection, I can measure the headway from the time it turns into green and the time this particular vehicle crosses the zebra line in that particular intersection. So that is going to be the first headway. Second time headway is between the two vehicles. And then again, it will keep on going the third headway, fourth headway, so on and so forth. So if I'm just going to measure the multiple headways, as you can see here, each headway is going to be lesser than the previous. The first headway will be the highest because the vehicle is just standing there, waiting for the signal to turn to be green. And once it turns green, the vehicle can just move. So some kind of a perception reaction time will be lost in this particular case. So when this perception reaction time takes, you can see that the first incremental headway, I'm denoting it as delta I, is going to be considerably higher than the previous one. The next vehicle will take less time, and the third vehicle will take even lesser time, and the fourth vehicle will take slightly even lesser time. And maybe around the fifth and sixth vehicle, you can see that the headway kind of turns to be a constant value. And this constant value of headway that we are designing at every intersection is called saturation headway. That means the headway that is getting saturated based on the traffic flow at a particular intersection. Now, in most of the time, when we are talking about saturation headway in typical systems, because when we don't have real-time data, what we normally do is we assume the saturation headway to be a value. We assume something like 2.5 seconds. That there are 2.5 seconds between every two vehicles moving in a particular highway. So those kind of assumptions we'll make, and we calculate the saturation flow rate. That means what is the hourly flow if there is going to be continuous green time in that particular intersection. I'm explaining these things to you because you understand what goes behind these adaptive traffic signals. Now, when we don't have, for example, much information on these kind of different time components, what we do is we take some assumptions and then we'll keep on designing the traffic signal like this. So you can see, for example, here, I'm having a red time here, and then I have something called a startup loss time. That means some time will be lost, which is not being used for movement, and the movement will keep on increasing. It will keep on rising. It will reach the maximum possible saturation flow rate when the headway is achieving the saturation headway, and the flow rate will not be consistent. It will keep on variating. And finally, after all the variation, it will come out to be amber time, and then suddenly it will reach out again the red time. So this is a typical movement when we don't have much information on the real-time traffic flow. So what we can do is, so typically when we talk about the cycle time of a particular signal, what we do is we try to understand the traffic flow in that particular intersection, and we try to relate the maximum possible critical traffic flow with the saturation headway that is denoted as 1 by h, where h is the saturation headway, where 3600 is the time that we have in 1 hour, 3600 seconds, minus n, the number of phases that you have in a signal, multiplied by the time lost in each of these phases. Okay, so if we have two phases, and if we are losing 6 seconds in each phase, 2 multiplied by 6, 12 seconds will be lost, multiplied by how much ever cycles are there in one phase. So there are multiple cycles in each of these intersections. So if the cycle time is C, 3600 by C will give my number of cycles. So using this formulation, typically we carry out the calculation for cycle time. So the unknown here tend to be C, because we can actually calculate the VC value. Okay, so in this approach, the drawback is that we are not accommodating for the need for variations in saturation headway. We are not accommodating the need for multiple, traffic flow values in an intersection. So what we can do is, when we get some real-time data, we can try to use something called an adaptive traffic signal. And this adaptive traffic signal can really change the signal timing, each component of green time. For example, in one phase, the signal time, the green time will change based on the traffic flow. And we try to keep on giving some incremental increase depending on the traffic flow till it reaches the maximum flow. And once it reaches the maximum possible time for a particular phase, it will move to the next phase. Okay, so this is kind of the background of how we develop adaptive traffic signals. This can increase the efficiency of traffic signals by multiple folds. Okay, so I will give just one case study, one quick case study on this, how we can increase, how we can improve the efficiency of traffic flow in different intersections, specifically in the case of heavy winters. So this particular study carried out by us using the data from multiple intersections in Canada, different Canadian provinces such as Manitoba, Alberta. So the idea was that when we have the saturation headway, traditionally we use some constant values, and when if we can get real-time values, right, and based on different weather conditions, there will be different saturation headways. How can we try to better inform the traffic signal design in these kind of transportation systems? This is a very unique case. Similar studies can be conducted in India also, with some adverse weather conditions. Okay, so we try to understand multiple intersection systems. You can see the sketches over here. In each of these intersections, what I have shown here is the different phase design for these signals. So you can see phi 1, phi 2, phi 3, and phi 4. These are the 4 phases that we have in these signals. And in each of these phases, we continuously collected data for multiple days, trying to understand each vehicle to vehicle movement, how much is the headway, how much is the different vehicle types which are there, and what is the weather conditions, things like that. So I'll just specifically go into some of the results. We tried to understand the weather conditions as dry, when the road surface is partly wet, when the surface is completely wet, when the surface is completely icy, when snow is there, ice is there on the surface. Sometimes it can be partially snow covered. Sometimes it can be completely packed on the road surface, or sometimes it can be completely fully snow covered, where practically you cannot see any of the road surface for movement. So in these different road conditions, now this is the power of data, right? Because traditionally, if I'm talking about a human-based, human-driven system, we have to manually do analysis, change the signal timing by ourselves. But when we have this continuous data collected on multiple days, over multiple years, maybe, we can actually have better models, which is kind of automatic, where the data will tell you that this is the optimum time for the new signal. So I'll just specifically give you some examples. There is a lot of results in this particular study. And all these studies that I'm mentioning are already there in the published literature. So maybe after my presentation, those who are interested can just see my website, or they can see my Google Scholar profile, where all these papers are already published. So if you search, for example, saturation headway, you can find this paper, which you can easily read. And if any of you are more interested, you can always email to me. I can share the paper to you as well. So I will give you one example where what we are trying to do here, the heavy vehicle ratio in that particular cycle that is given on the x-axis, the saturation headway that I was discussing is given on the y-axis. So when the heavy vehicle ratio, the goods vehicles are increasing, what is happening? Typically, saturation headway is also increasing. And how that increase is varying on normal days, partly snowy days, and heavily snowy days. So what we could find is that if we actually take care of this real-time data, the saturation headways are increasing by 13.6% in the case of, for example, partly snowy. But in the case of heavily snowy, it's increasing up to 38%. So there is a lot of need for these data-driven systems, which you can already see here. And similarly, the heavy vehicle influence also, something that we can capture using real-time data, which will actually help us to make better decisions if we take care of the traffic composition. Okay, so this is kind of a very clear example on how we can use these kind of dynamic data-driven traffic signal systems. All right. So with that, maybe we can move to the third application. The third application is on the incident detection and management. The idea is that now we are talking about these kind of AI based cameras, which can detect a particular incident as it happens real time. Many of you may have heard about AI based enforcement cameras that if somebody goes beyond a particular speed limit, suppose the speed limit of the national highway is 100 kilometer per hour, if somebody is going at 105, that particular vehicle will be captured, the number plate of that vehicle will be captured as an image, and that particular vehicle will be sent a challan so that he has to pay for speed violation. Now this complete system is automatic. There is no need for any manual intervention unless you give an option that a particular human, maybe a police officer, can just check and verify that it is correct, right? So these kind of systems are absolute marvels of AI based applications where we can identify the incidents quickly, and it can actually trigger some immediate alerts. For example, currently I am in Prayagraj, as I was telling you. Suppose there is some kind of crowding event where there is some kind of some collisions or stampede is happening, and if that stampede is happening, think about the potential. If a person can automatically, if a system can automatically identify a stampede is happening and alert that emergency services instead of relying on human based interventions. Because the benefit is that these systems can run 24 into 7, 365 days, right? So when we have these kind of systems, it will help for real-time deployment of emergency services. It will help for minimizing delay, improving the safety, lot of applications towards crowd density, crowd predictions, lot of applications are there. And that is why the good part is, because in India we have lot of smart city development, each of these cities have the infrastructure that is needed for developing these kind of algorithms. So the applications of AI in urban transportation management is immense, as I have been discussing with you. All right. So this is kind of the summary of what I have been discussing on the first thrust, that is AI-driven optimization of traffic and transportation systems. All right. The second thrust area that I want to discuss is how AI can be used in public transportation systems. Now, all of you understand what do I mean by public transportation systems. So these are systems such as the buses, the metros, the ropeways, the trains, the airplanes. The idea is that it's a publicly run agency, agency which runs a fleet of vehicles, which can carry different types of users going to a common destination. And these vehicles can be any mode, right? It can be any types of mode. And these public transportation systems, how can it be better informed using the power of data and AI? Okay, let us try to understand it in a bit detail. The first application that I want to highlight is the potential of demand responsive transport, or DRT. Because when we talk about public transportation systems at present, many times what happens is we decide the route of public transport, we decide the schedule of public transport, and there could be buses, some kind of shuttles, there could be some microtransit services. Microtransit means some kind of special buses which only runs in some particular routes, maybe with some reduced capacity. So how AI can be used for optimization and having some kind of demand-driven network design. So what we are going to use here, we are going to use the actual demand data about how people are traveling in a particular area. It can be based on real-time requests. It can be based on historical trends. It can be based on ticketing data. How that can be used for adjusting the vehicle deployment and the routes. It can reduce the wait times. It can reduce the fuel consumption. Lot of potential, because our public transportation systems are generally not very profitable in many of our states. So can we try to have more demand-driven services? So I would like to give a case study what we have done specifically for the Varanasi public transport on modeling the crowd or the occupancy within the public transportation vehicle and how we can use these kind of data sets. So I would like to give you that case study that we have done for the city of Varanasi. So I'll tell you why we are doing what we are doing in this particular test. Now, if I'm talking about prediction of public transportation demand, many of these tier 2, tier 3 cities, they do not have, for example, a data system where we are talking about collated data from the ticketing machines. So they have these electronic ticketing machines. The data is rarely collected and used for some kind of decision making. It's just used for some kind of revenue analysis. So our objective was that can we use this ticketing data to derive some measure of how many people are inside a vehicle at different points in a transportation system. Can we use it to predict the occupancy within vehicle at different points of time and at different points of the route? Now, with real good prediction accuracy, if I can predict the occupancy, that will help for optimizing the bus route. We can improve the schedule. It can enhance the service quality, and ultimately, it will benefit the bus riders, right? So, with this background, we were trying to understand how to develop kind of an occupancy prediction model, and I would just like to highlight you what exactly we did. So I'm just showing you, for example, the different bus routes and the different stop locations that we have in the city of Varanasi. So approximately the ridership within the city are not that high because Varanasi, we have a lot of e-rickshaws and other types of mode. On a given day, we could find that the diesel buses were having a ridership of around 7,658 passengers. There were about 26 routes. There were about 56 buses within the city area. There were a lot of electric buses separately. Ticket price, the stops, all these locations were digitized. And after collecting the ticketing data, the electronic ticketing data, we try to analyze the demand and the schedules, right? So we try to assess how much percentage of demand is being utilized. We use this manual ticketing data, digitized it. We developed a GTFS, that is like the Google Transit Feed specification. We developed the routes, we developed the schedules, we developed the nodes, we developed the different types of shapes and different types of stop times. And after developing all these entire public transportation system, we also try to understand the social demographics. What's the household density in an area? What's the population density? Different types of publicly available data. We use some geospatial data sets as well. And then we try to predict the occupancy over multiple days that we have collected. And we try to distribute it, as you can see, over multiple days. And using these values, we try to predict using multiple types of machine learning algorithms, random forest classifiers, XGBoost classifiers, random forest regressors. The idea was that can we use the past wealth of data that we have and try to predict the occupancy for the future. So I'm not again going to too much of detail here. Those who are interested in the research, and because all these are individual presentations, which again goes for more than 1 hour. So I'm just giving an idea. I'm trying to show you, for example, the heat map that we developed. And ultimately, can we have like a dashboard, as I was telling you before, where if you just click, for example, the day and the time period, it automatically shows you the predicted or the forecasted occupancy within that particular stop. Again, a great application of how we can use it for the prediction of future ridership, right? So this is a great case study that I can say how AI can be used in the public transportation systems and how it can be used for better decision making. Now, another application I want to highlight is how AI can be used for predictive maintenance. Now, predictive maintenance is something completely different because we cannot do that based on the demand data. So for that, typically we use the onboard diagnostic sensors. These sensors are basically linked to the engines in a particular vehicle. It can be buses, it can be trains, or it can be any types of public transport vehicle. And we are trying to understand how different types of vehicles and drivers are operating. What is the acceleration and braking characteristics? If it is an EV, what is the battery state of charge? We are trying to understand how the wear and tear inside the vehicle is there. Now, when we have this real-time OBD data, onboard diagnostic data, we can track it and try to predict the downtime, see when do we need to schedule the maintenance for a particular vehicle. So what is going to happen? The vehicle is going to have better performance. It will reduce the unintended energy consumption. It will improve the driver behavior. So because we are already analyzing the driver behavior, and we can completely avoid the unexpected breakdowns. So this is another great application where we can use the historical data from onboard diagnostic sensors and how it can be used for better predictive maintenance, right? And lastly, I'm just trying to tell you another application where we are talking about smart ticketing and fare systems. How AI can be used to optimize, for example, pricing. Suppose I'm developing a metro system where at different points in the day, I'm going to have different pricing. Okay, so it's kind of like a dynamic pricing system where the pricing is based on the demand. Maybe it is a peak day with a lot of demand for a particular festive reason. Can we talk about a separate pricing, which can again maybe try to reduce and manage the demand? Because ultimately, pricing is also an incentive or a disincentive. So, can we talk about dynamic pricing based on demand, based on time of the day, or even just the congestion level? If the system is already congested, we can actually keep the pricing based on the congestion level. Again, that's based on the real time values that we get. So that can actually talk about these ticketing systems where the dynamic pricing is changed based on a software program that we are writing based on different inputs of demand, the time, and the congestion level, and some forecasting algorithm. So I would like to just highlight one paper that recently got published from one of my research group, which was actually on how digital payment, all these digital smart ticketing systems, are to be adopted in a public transportation system. This is a study that we actually did in Jodhpur using a sample of more than 3,000 respondents. It was a data collected part of Transport for All challenge, where multiple people were surveyed on their willingness to use these smart ticketing systems. So we could collect data on age, gender, household size, household type. We also tried to get a lot of information on the attitudes of people, on how people perceive public transportation systems. Are they finding it uncomfortable? Are they finding it unsafe? Are they finding it, inconvenient? And using these kind of indicators, we were trying to find out different types of commuters, different types of people who are using public transportation systems, and can we use some machine learning algorithms to predict the willingness of people to accept these smart ticketing systems? Because in these kind of tier 2 and tier 3 cities, we have to talk about how we increase the adoption of these new technologies. So we were trying to give policy recommendations for the government. So specifically using this was a study that forgot to tell you that not Jodhpur. This was a study that we did in Kota. So in Kota, when we could collect this sample using multiple surveyors, using face-to-face interviews, some were based on web-based responses using this Transport for All challenge, and we identified different segments of commuters. Some were satisfied public transportation users, some were access concerned intermediate public transport users, some were satisfied two-wheeler users, some were information concerned two-wheeler users, because they are telling that they are not having enough information to use public transportation system. Some people were concerned about the comfort in public transportation system, so we named them as comfort concerned car users. Some were concerned about the safety, so we were mentioning them as safety concerned captive public transportation users, because they were using public transportation regardless. Then there were comfort concern two-wheeler users. So all these different segments of commuters were identified, because when we talk about policies, the policies need to be targeted for different types of commuters. So after collecting these different types of latent classes using statistical analysis, we could try to understand what kind of policies and how their adoptions are varying. So we could target, for example, for each of these commuter segment, what policies the government could do. Sometimes it can be about improving the information. Sometimes it can be about improving the safety levels in different parts of the routes, and how we can actually implement the smart ticketing systems throughout the country. Because now with the advent of different types of UPI based systems, it can be Google Pay, we can actually talk about smart ticketing in a much seamless manner, where the data can also be stored much easier. So this is kind of one application that I wanted to highlight, how AI can be used for public transportation systems. Now, the third trust area that I want to highlight is how AI can be used for sustainable mobility solutions. Okay, so what do I mean by sustainable mobility? Now, when I talk about sustainability, the first thing that comes to my mind is always walkability. Are we talking about an infrastructure that incentivizes people to walk to multiple destinations? Now, again, walkability is something again that we have to deal with in terms of urban design, developing infrastructure, things like that. So that is one part of it. Another part of sustainability could be public transportation, as I was discussing with you in the previous thrust area. Another type of public transportation could be bicycling infrastructure. How do we develop bicycling lanes and things like that? Now, these are all part of sustainability. One recent focus that has emerged in the sustainability sector is how do we talk about electric vehicle infrastructure? Now, all of you know about EVs. The idea of EV is that we'll have a zero emission vehicle where there is no tailpipe emission coming from the particular vehicle that we are driving. Now, the challenge is that now there is a lot of incentive from the government to have widespread adoption of electric vehicles. Now, the challenge that we have when more and more people are adopting electric vehicles, how do we decide the locations of public charging stations? Because many of the times what happens, we do not have much information apart from, for example, the population and things like that. We do not know what should be the optimal locations for charging stations. Sometimes people just put EV charging stations in the petrol pumps. So these approaches are not driven by the real potential of the data. So one application of AI can be how AI can be used to predict demand, and this EV charging station should be kept in areas with high demand, which are equipped with enough charging ports. So there could be slow charging or there could be fast charging, and there are different capacities of the EV chargers also. How do we allocate these kind of a charging location problem, a location allocation problem, with the benefit of AI? And AI can also optimize the energy distribution because ultimately we are talking about a electricity grid also. How do we ensure that these charging stations are powered in an efficient manner? How do we talk about grid capacity, peak electric energy demand? So many people from electrical engineering might relate to this better. And what we try to do, the case study that I want to highlight, is a work that we did in New Delhi recently. So this is another paper that is published in the journal Energies for Sustainable Development. So let me give you some highlights of the case study that we did using the methodology that we had. So what we tried to do in this particular study was propose a new equity-based approach, because the idea was that let's not leave anybody behind in transport electrification. Let's not focus on the people who are already EV users. Let us go for a population-weighted approach where everybody will have access to a EV charging station in a particular city. And New Delhi was kind of the ideal place for a case study like this because there was a lot of uptake for electric vehicles in that particular city. Second, there were a lot of government policies also which targeted to achieve at least one EV charging station in a buffer of 3,000 meters within 3 kilometers. And the previous studies also indicated that the maximum distance that a person is willing to travel for accessing EV charging is about 6.8 kilometers. So our objective was, can we analyze these different trade-offs? What about the policy target by the Delhi government that every EV charging station should be there within a 3,000-meter buffer? And what about maybe we are going for something much higher, something like 6.8 kilometer? What about the policy trade-off? How much more charging stations need to be made based on the real-time demand that we are capturing, right? So again, I will just highlight the work that we did mainly for the city of Delhi, where I mean you can easily understand the background. There were many public transportation routes. There were many public transportation terminals. There are a lot of road length as well. There are multiple agencies in charge of planning for the city, whether it's the DMRC, whether it's the Delhi Transport Corporation. We have a DIMTS. So there are a lot of agencies as well. And there has been a lot of focus on sustainable urban mobility too. And all of us know the concern for urban mobility and air pollution in our capital city. So with that focus, we try to understand, for example, the mode share in that given city. Again, we try to understand the different modes people are using, whether it is public transport, intermediate public transport, non-motorized transport, all these different alternatives. And what are the mobility challenges? Because this is a city with a lot of private car ownership, with a lot of pollution levels, congestion continuously increasing. With that background and the focus on emissions, there were a lot of focus on EV adoption. So the FAME policy could actually increase the EV adoption rate in the city. So that was definite, benefit that we could see. But what we did not know is that whether the charging stations already being developed in the city, is that developed in the most efficient manner or not? If it is not, can we propose a methodology which will tell you how do you develop the new charging stations so that there will be equitable access for everybody, right? So without, for example, tackling the challenges such as higher cost, range anxiety, because whenever we are talking about purchasing a new electric vehicle, the first challenge that comes to most of the users' mind is the range anxiety. What if my vehicle runs out of charge, right? And there is also a lot of limitations in the charging infrastructure also, because again, that's something that will take time. So what we could understand was that there is some gap in the way that EV charging stations are developed. So what we did, we try to develop a database of all the EV charging stations in the city. So that is what I have mentioned here as EVCI database, electric vehicle charging infrastructure database. We also took data on the demographics, the population, the income, the electric vehicle ownership. We used a novel data set on the Google building. So the building footprints are already available in a publicly available Google building dataset, where every building is mapped and its footprint is known to us. Now, using this information and using the electric vehicle ownership at each ward. So the census ward that we have taken, that's the basic analysis unit. We performed an analysis called enhanced two-step floating catchment area method. Again, I'm just telling you what we can do with the data we can collect. So using these, we try to report the accessibility ranges at every 100-meter grid in a particular city. And using the accessibility analysis, we try to understand how we develop charging stations in the urban areas and how do we develop charging stations in the suburban fringes, right? And finally, we will allocate the charging stations which will improve the equity levels so that everybody will have access, at least at the level of 3000-meter buffer radius, right? So this is kind of the background of what we did. We used a lot of data set. This is a work that kind of spread across the last 1 year. And the paper was also published very recently, maybe 2-3 weeks back. So this is again a paper that is publicly available. You can check it in my website as well. We collected the Google building footprints. We collected the road network. We collected the population density, ward-wise electric vehicle ownership density, and what are the potential locations. So this is the current locations of electric vehicle infrastructure in the city. And using the methodology that I was telling you, focusing on the people, focusing on the service capacity of each supply, the idea was that how do we find the number of supplies that are required in the search area that we are checking. So we performed a sequential analysis with a service area buffer of 3000-meter, which is the target policy of the city. And after a lot of analysis, we could kind of allocate the EV charging station. So what you are seeing in this particular figure is the potential locations which are optimally placed, the new locations which will help us for addressing the equity concerns. So within the city, we have used one approach, kind of a normative approach. And outside the city, we have used something like a demand-based approach, where we are again, okay, there is a demand over there. Let's try to provide some charging stations over there. So using this approach, we could say that if we are developing, for example, 109 new charging stations in the urban core and about 150 stations in the peri-urban areas, which are beyond the urban core, in total, there are about 259 stations. This will cover about 93% of the population of the city of Delhi. And that actually addresses the equity concerns. So instead of randomly placing the charging stations based on petrol pumps or corridors, if we go for a demand-driven real-time method, as we are proposing, with about 259 charging stations, it will cover about 93% of the population within 3000 meter from their buildings. So this method, again, I believe, exemplifies how data can be used for better decision making for urban infrastructure decisions. And another application I want to highlight is how real-time data and AI can be used for urban mobility integration. So I would like to highlight a couple of things here. Now, whatever I have told you so far, that we have used data on the publicly available systems, data on buses, data on trains, data on bicycles. But there is another potential that we can talk about on social media data. The data that we can collect from Facebook, data we can collect from Twitter. Now, this is a great avenue for a lot of research and implementation. So what we did before Twitter became X, I'm talking about 2 years back, before Twitter became X, we tried to use some openly available APIs to collect the data on how people are talking about electric mobility in Twitter, right? In the Twitter space, when somebody is tweeting, and these tweets are made for the last 10, 12 years. I'm talking about the data that is available from 2009. And we're talking about millions of tweets, right? Where different people are talking about some keywords. And these keywords are something like somebody is tweeting, they're interested in Twitter, interested in some particular like EV. They're talking about some brands of EV, maybe Tesla. So all these conversations are recorded in millions of tweets, which can actually be captured using multiple APIs and we can download. And once we have these APIs and storing the corpus of text, using, and this method is something that we call as data mining. Once we have this corpus of text, we can analyze the sentiment of people from that text. Now, the benefit is that in these kind of approaches, we can actually collect data on the entire world. We are talking about Twitter users spread across the entire world, and they're tweeting from some locations, and that's their location of their opinion. Now, how we can use this kind of a data set, and it's a very rare and unique data set, and can we use that sentiments in data from Twitter? Can we use it to predict the electric mobility adoption across the world? So this is again a paper that we could write and publish in the journal, a prestigious journal, Transportation Research Part D on transport and environment, how we can use this new data source for electric mobility adoption. So what are the objectives of this study? How do you track using the benefit of real-time data, the improvement in public awareness on electric vehicles over time? Right? There is no other way where we can collect data for 12 years across the world unless we focus on social media. So the benefit was that when we were doing the study, that time it was publicly available. We could just extract it. The unfortunate part is it is no longer available. I think recently when it became Twitter to X, but still there are many ways in which we can still request for tweets and possibly replicate the study for many other purposes. So still, there is a lot of potential for using Twitter data, Reddit data, Facebook data, how these different social media platforms can be used for sentiment analysis. And how can we use these kind of a unique corpus of information for understanding the influence of climate change events, some EV related events, and can we use it to predict the adoption of EVs across the world, right? Something very unique and interesting. So in the conventional methods, when we are struggling with smaller sample size of data, where we are mostly depending upon questionnaires or online surveys, it generally is very constrained about just a very small topic. No matter how big of a survey that we design, we cannot capture much temporal variation. Now, if you want to capture some variation, you have to do the survey multiple time periods. It requires a lot of resources. No matter how much time and effort you spend, the survey will still be limited to a specific region. So the conventional methods are clearly falling short over there. But if you are going for a data mining approach, what are the benefits? It captures a much larger sample size. I'm talking about millions of tweets and users. Uh, this was such a big data set. Handling it was so challenging in our computational resources. And now, once you have this big data set, can we capture the exact opinion? Because ultimately, we are having a text. Using the text, can we capture the sentiment? Is it positive? Is it extremely enthusiastic? Is it negative? Are people losing interest? Can we capture this variation over time? Now, when we have a data set, the good part is it doesn't require any surveys. We don't have to go and spend our time in the field, and the data is completely global. It is not from one particular country. I can get it from the entire, multiple countries in the world. And now the only challenge, now there is a drawback for this approach also. The drawback is that social media is largely used by the younger cohorts of people. And we may not get any information on the people who do not use social media. And what about the people who do not even have a smartphone? So definitely, this is kind of a convenient sampling. We cannot have all the people to use this kind of social media networks. But still, nonetheless, because traditionally, these kind of social media platform tend to be the early adopters of these new technologies. So it is widely seen as a potential platform for understanding early adopters. So that's kind of the approach that we did. So we started by mining the tweets from Twitter. try to understand how it varies in terms of sentiments over time, try to link it with multiple sustainability events on different climate change conferences. We try to understand at what point it changes. Can we understand the change points? And can we model the different topics of discussions individually? Right? So we use multiple Python packages, try to use search queries such as electric car, electric bike, or e-bike, or electric vehicle. We focused on tweets from January 2012 to May 31, 2022, the point in which we were doing the analysis. We collected the corpus of data, removed the mentions, removed the hashtags. For example, there could be some kind of unnecessary redundancies. We try to remove that, and you can already see there is about 5 million of tweets which we have used, where we have data from more than 71 countries, right? So using this data, we try to link it with the pre-pandemic period, before the COVID-19 pandemic, during the pandemic, after the pandemic, how these sentiments are changing. Again, something very interesting. We also try to divide into multiple periods based on different EV events. You can see period one, 2012 2015, period two, period three, different points which are based on the public events during that time, and how it basically changes. So the sentiment basically varies in a positive value. It can be varying between 1 to -1. So it will be positive. It is considered to be positive if it is between 1 and 0.05, because ultimately we are converting the text sentiment to a particular number. Because as an engineer, my objective is always on the quantification side. So we have used a particular lexicon called Vader, where if it is between 0.05 and 1, it is positive, as you can see. If it is between minus zero point zero 0.05 and 0.05, it's neutral. And if it is between minus zero point zero 0.05 and -1, it is considered to be absolutely negative. Now, these kind of analysis will help us to understand the sentiment. We try to understand the change points based on a PELT algorithm. We try to understand the topics within each of these time periods for better understanding of the discourse. So you can see, for example, how the activity on EVs vary over time. We try to go with this weighted analysis. And after that, we could. So what you are seeing here is how the sentiment varies. Now, these positive sentiments are shown as green, neutral sentiments are shown as gray, and negative sentiments are shown as orange. Now, you can see how these different points are changing and how they are potentially linked on the graph that I have shown below. These are the different compound scores, right? And the average values of sentiment on each of these points. And that we try to link to the different themes of discussion we had. So what is the ideal case? What is the worst case? What are the different events that had a compounding effect? What are the underlying events? Can we link it for the adoption of EVs across the world? So a lot of discussions we had in this particular paper, linking it to environmental conservation, political decisions, business decisions. So you can find a lot more discussion on this particular topic, and specifically linking to the different change points, right? How this EV adoption changed during different times of the pandemic. You can even see, for example, in different parts of the world, I'm doing some clusters of analysis where some parts are having, for example, more adoption, some parts are having kind of a medium adoption, some parts are having kind of heavy adoption, right? So these kind of different sentiments and how it varies across different regions was something we could analyze. And we could also kind of list out the reasons for resistance towards EV adoption, how that can be linked for charging infrastructure, how can we improve it based on charging infrastructure, vehicle technology, or some kind of economics and policies, right? So more information on these discussions can be seen in the paper. You can find it in my webpage also. The idea is that now this is a very unique data source. Whatever I have been discussing, all of them were discussing on data on multiple modes of transportation. Now, this particular example or case study, what I have shown you, is how we can use social media data for the EV adoption. So that's a very unique application, right? How the public discourse can be mapped and how that can be used for better decision making. Again, in the AI-driven futures that we are talking about, right? Now, the last application that I want to highlight on this particular thrust area is how we can use shared mobility systems, how we can talk about a mobility system that are used by multiple people and have coordination between them. I'm talking about car sharing, bike sharing, or some kind of ride hailing services such as Ola or Uber, and how that can be used for predicting the demand patterns. And using that, we can better optimize the fleet distribution. Like, where should we keep the bike share stations? Where should we keep, for example, the new ride hailing vehicles? What's the location that we should keep them? And reduce the number of empty vehicles. Nobody wants to have empty vehicles on the road because there is nothing but a deadheading that leading to inefficiency. So we should try to have more efficient use of resources, reduce the number of private cars, and overall helping to reduce the emissions as well as congestion. So specifically in this particular topic, currently we are executing a project by Indian Council of Social Science Research, where we are trying to develop a e-bike share project, specifically focusing on the location allocation, on the fleet distribution, so on and so forth in Varanasi, right? So maybe more insights on it can be shared once we are exploring more on this particular avenue, right? So the final application I want to highlight, and then we can go for some question and answer session, is how AI and environmental impact reduction can be used, hand in hand. So one application is how AI can be used for emission monitoring and management, how these AI systems can analyze real-time data. And when I say real-time data, I'm talking about sensors kept in vehicles. It can be GPS-based sensors, some kind of probe vehicles. In the urban infrastructure, can we use these vehicles to track emission levels? It can be some static points or dynamic points. And can the city agency identify areas of high pollution? And based on the real-time the information that we can we deploy some targeted interventions? So can we have some kind of targeted pollution reduction towers based on the models that we develop? And using the trends that we can analyze, can we use AI to implement some kind of emission reducing strategies? I will give you an example such as low emission zones. So these are zones where maybe we can completely ban private vehicles. These are residential, this could be residential zones. Maybe we can implement congestion pricing. In congestion pricing, what we are trying to do, this is something that has been done in Singapore and London. The idea is that can we charge the users for the congestion that they incur in the road space? Because traditionally we try to what we are doing is we are giving an impression that the road space is free, and all we are charging is basically the toll. What about the congestion that somebody is causing? What if the capacity of a roadway is 100? The 101th vehicle is causing some congestion on the remaining 100 vehicles. So can we talk about some kind of charge? If the vehicles are traveling in the peak hour, they should pay some extra amount of time if they're traveling beyond a particular capacity level of the roadway. Now, then what happens is it will kind of incentivize the people to shift towards public transport, and naturally you will see a reduction in demand. And can we talk about some kind of real-time policies which will promote the use of electric vehicles? So this is kind of the larger applications on emission monitoring and management. Another application of AI in this direction towards environmental impact reduction can be towards the reduction of eco driving, to assistance of eco driving. How these AI-driven systems can be integrated into our vehicles, and some of this can already be seen in our newly purchased vehicles, where they have an eco driving mode, but that's more like a engine-based alternative, where we are just trying to say that okay, I want to have an eco-friendly behavior from the engine, but I'm talking about eco-friendly driving behaviors. Can the car or the vehicle give kind of a prompt that okay, if you drive on a particular speed, if you go for an acceleration deceleration pattern in a particular way, this will help for much better environmental performance of the car. There will be much reduced emissions. Now, this will be completely based on the analysis of driving patterns. It has to offer suggestions to improve fuel efficiency. How do you adjust the speed? How do you adjust the braking and acceleration techniques? When should we do it? How do we avoid the sudden braking? Things like that. And when you have a fleet of vehicle, it can also be used for route optimization to reduce the fuel consumption and all emissions. This is kind of the second application that I am suggesting in the case of AI-based environmental reduction measures. The last kind of topic I have is how we can use data-driven analytics for urban planning. Because traditionally, when we talk about model shifts, when we talk about traffic patterns, most of the time what we do is we try to understand the existing demand, we try to predict some kind of scenario analysis, and we say that okay, based on this new policy, based on the scenarios that we have analyzed, this is going to be the change in the system. Now when we have AI based algorithms, the benefit is that whatever data we have collected, right, and those data can be used for very minute, robust sensitivity analysis, which can tell you if I do this policy, this will be the corresponding impact. If I modify the policy by this much, this will be the corresponding impact. So there is a lot of scope on sustainable mobility analytics, specifically for the urban planning purposes. So I would like to just give you a couple of one last case study on maybe after this we can stop and take some questions. How people with disabilities are traveling in India. Now, this is a topic that I think are very important because when you talk about sustainability policies, one of its important aspect is inclusivity. Are we talking about people with different needs? Now, when we talk about people with disabilities, imagine if I want to understand their travel behavior, generally it's very difficult to get the data unless you do a very wide survey. So what we try to do is we try to get a large sample of data from the Ministry of Statistics, and using that data with more than 1 lakh users, right? How are we going to develop some data driven policies? And that sustainable mobility analytics will help for better inclusivity policies. So this is kind of a case study that I wanted to highlight. So what we tried to do was that we understood that this is a case where urgent policies are required, typically the travel patterns of persons with disabilities. So PWDs basically stand for persons or people with disabilities. And generally their travel patterns are very complex because they travel in multiple trip chains, they use multiple modes, and their travel decisions are quite different from the abled population. And you can also see that many of them are making fewer number of trips in reality. And their trip distance is also much shorter because most of them are dependent on the public transport. And the question is also how do we design our public transportation systems to be more inclusive for the persons with disabilities? So what we did was that we tried to evaluate the asymmetry in mobility barriers and different types of barriers that they are facing. And is there any regional disparity in their transit usage? Because the data that we had, it had data from all the states in India. Can we understand some regions where more targeted policies are required? Can we look for its correlations with district level economic features? Can we try to talk about some specific policies on its impact on different types of targeted improvement policies? Right. So what we did was that we used this survey where about 1 lakh 2,977 people with disabilities were surveyed. We tried to use each of those responses in one hand in disaggregated level. We also try to aggregate at the level of district so that we can understand how their barriers are changing across different states and cities and districts. Now we also try to predict the transit mode share, how public transportation mode share is changing. We use different kind of econometric models ranging from a ordinary least square model to structural equation model. At the individual level, we tried different type of logic models in terms of predicting the usage of public transportation as well as the barrier. So again, I will just highlight the key findings. We tried to understand, for example, we could find that especially when we talk about gender, women with disabilities were found to be less likely to use public transit. Different types of people with disabilities were there. Somebody with locomotor disability, somebody with something like a intellectual disability, somebody with hearing disability, visual disability. All these different disabilities were found to have very unique choices and barriers. We found that some of them were having difficulty in accessing the entrance of the vehicle. Some of them were having difficulty in opening the doors. Some of them found it difficult to find seats. Some of them had lack of information, basically, in terms of how to get to the public transportation stops. Some of them had, maybe they didn't face any difficulty. Some of them had difficulties they cannot quantify. So all these different type of barriers we try to model. We try to have like a nationwide disparity analysis where we could see that some particular districts, we could find that they were having some type of disabilities were not using public transport. In some particular states, we could see that another type of disability is not being utilized. So, for example, we found that in Uttar Pradesh, for example, we found that there were some clusters of a lot of public transportation usage found in people with locomotor disabilities. So that could be because of some policy in that particular state, and some states also found to have very less usage of some type of disabilities. So the idea is that can we have very regional specific policies? Again, in the past, we did not have any data on these things. Now, with the power of data, with the power of models that we develop, we can actually have better decision making, which is not based on empirical decisions, which is not based on just simple models that we develop. Instead, we can have a corpus of data, instead of we can have a corpus of models which can have better decision making. Now, there is a lot of applications that we can think in this direction. The idea is that we can have better policies, we can have systems where there is not much bias in terms of decision making. So the potential of AI in urban mobility analytics is a lot. So all in all, I would like to summarize my presentation that the four thrust areas that I mentioned, it could be AI for traffic optimization, real-time traffic optimization. It could be AI for public transportation systems. It could be AI for sustainable mobility analytics, or it could be AI for environmental impact reduction. All these are very unique applications where a lot more things need to be done in a country like India. There is a lot of potential for improving the efficiency of urban mobility systems. And I hope this particular talk has given a lot of food for thought for all the participants. I'm hoping those of you working in different areas may have gotten the motivation and many ideas where you can conduct research, work with the government. See, the idea is ultimately to make a difference, right? All of us are trying to make a difference with our work. Can we try to impact, some kind of a change in the actual physical infrastructure system in terms of improving the, efficiency of urban mobility movement? Right. So maybe with that, I would like to conclude my discussion. I think we can have some kind of a question and answer session as well. If any of you have any discussion for the next 10 minutes, we can have some Q&A session. You can find a lot more information on the talk that I gave if you visit my website. I have a research group that I'm leading at IIT BHU RNSE called Sculpt Lab. It's sensing and computing for urban logistics, planning and traffic, Sculpt Lab. So you can find the papers that we are writing. You can find, for example, some of the teaching material. And these kind of FDPs are the ways in which we try to have better outreach for the general public. So I hope you found the talk useful and we can have some discussions now on the topic. Thank you. Thank you, everyone.
Thank you, sir. Participants, yes, if you have any query, please write in the chat box or unmute your mic.
Feel free to write your comments in the chat box. I can answer it to you. And even after the session also, you can feel free to email me. I'll always be happy to answer your queries. Yeah, I can see one comment by Samiksha. Well explained. Thank you. Thank you, Samiksha. I hope you found interesting the whole discussion interesting. Yeah, I can see there is a question by Sneha. Good evening. How do you think inclusive approach towards like for physically disabled will impact urban traffic flow or mobility flow? Yeah. So the idea is that right now we never had enough information on the mobility of disabled people. So now with the advent of data, the data set I'm talking about is from 2018. So what we are trying to do now is when we have a better inclusive approach, the idea is make sure that our public transportation systems are accessible and inclusive for everybody. And naturally, we are hoping for more participation from these disadvantaged groups, and they can use our public transportation system, which will improve the overall equity of the system. So that's something that I think is very important. It may not have a lot of impact in terms of traffic flow because we are specifically talking about public transportation system. It will just make the system more inclusive. Yeah. Any other question? I can see a lot of information. Thank you. Thank you. I am glad that all of you found the session to be useful. I would really recommend those who are interested to get in touch. You can always find, you can So I am working in ITBHU. You can always feel free to send some of your students for internship programs that we have. We have a relatively smaller group, but I'll always be happy to accommodate some requests from any of you because I can
I
see
have
that many of you are professors. Yeah,
Yeah, I have a small question.
please.
Uh, I'm Dr. Manchkanti.
Yes, yes,
The actually when the as they say na, the new god is data.
yes,
So data. Now the accuracy of prediction will depend upon the quality of data.
absolutely.
Now, how do we ensure the data? Because every time we may not get data from primary sources. Most of it
Hmm,
can be is sourced only to secondary sources. So, how do we check whether the data is of good quality?
right,
That's number one. Number two, inclusivity is something which you already mentioned in your presentation. Moving towards public transport, cycling,
yes.
and walking. Why? The second question is like, why are we not successful in that department?
Right. Okay. Thank you.
Thank
Thank you
you.
for the question. So the first concern was the data quality, right? So whenever we try to work with many of the cities, I completely agree that data quality is a primary concern. So what we normally do is we try to ensure that the data is from, for example, electronic sources. So if you talk about electronic ticketing machines, these are data that we can absolutely, rely on. Still, there could be some kind of anomalies and outliers. Again, we have some statistical methods to treat these anomalies. Sometimes we can go for data imputation techniques also. So the idea is that when we rely more on these kind of electronic sources, we use GPS based data. Unless we have a faulty sensor, most of the time we get very reliable data. So because of the cyber physical systems that we are talking about nowadays, it's not relying on just somebody's responses in a survey. It tend to be much more accurate than the traditional ways of doing a survey, trying to understand from a household. So the traditional approach is kind of flawed because naturally it's very difficult to verify its authenticity. But when we have these kind of electronic sources, digital sources, they tend to be much more reliable. Still, there could be some kind of outliers in the data which can be identified and treated. Now, the second part is why we are not very successful. The cities are not very successful in terms of addressing the inclusivity challenges. So, this is a concern throughout the world. I'm not talking about just India. The challenge is, of course, when I'm talking about India, the challenge is also the population. Also, we have a geographically diverse, large country with a lot of population. So, when we have a lot of demand to cater, naturally there will be a lot of challenges of inclusivity also. And every transportation system has the issue of ridership versus coverage. So in the last 3 4 years, lot of this publicly available data has really been coming to this particular domain. So I would say you can see a lot more measures and policies in the next few years. But I completely agree that at present we have a lot of challenges. Not every city is equipped to deal with these kind of data-driven challenges. Not enough models are there. There is a lack of skill set also in terms of availability of manpower, availability of people who can use these data sets also. But I think I'm quite optimistic that in future it will get better. Right. So let me also take a couple of other questions from the chat box. I can say that there's a comment from Ms. Viji. Can AI predict and prevent overcrowding in public transportation? Absolutely. So what we are trying to do, for example, in cities like Varanasi, we are trying to collect data on crowding inside the vehicle, right? So once we have this occupancy data within the vehicle, once you extract that, we can actually have good models predicting spatiotemporal variation in occupancy. And once we understand this occupancy variation, that can be used to, I'm predicting high level of occupancy on a particular day. Maybe I can provide an additional bus in that route, which will help for reduction of overcrowding and those kind of events. So definitely, yes, it can definitely help for overcrowding prevention. There's another question also. Public transportation needs infrastructural changes, but as a person, can we think about analytical application for PWD for guiding transportation facilities? Yeah. So what we can always try to do is try to understand the pain points that a person faces in terms of accessing a public transportation facility, how they travel inside a particular vehicle. So there is a lot of scope in terms of improvement in this particular area. I remember when I was working in the US, there was one company which used to make different kinds of glasses and some kind of packages, some baggages. If you wear that, it will make you feel the mobility challenges that people have. It will make you feel like you have some kind of a mobility impairment, and how you move. It will make you understand the challenges that a person with disability has. So this kind of many types of sensitivity training can be given for people to understand these challenges better and design the infrastructure better. There is another question. Uh, okay, I think there is another question about connecting. Somebody has raised their hand. Maybe they can ask their questions. Is there any more question? Yes, Professor Kiran, please. I think we're already around the time.
Uh, Professor Krati Sharma
Yes, please,
raised her
please.
hand.
Dr. Karthik.
Okay, good evening, sir. It's a wonderful session. I have one query because see, I am a scholar of humanities. So when I see like
Yes,
there are challenges for the blind, especially because see they have the
yes,
braille. Okay, fine, that's okay. But what next? How we can make their life more
yeah,
easy for this disabled? Because see, there are so many students who are not able to access the braille as well. So being how
yes,
AI
I
can
absolutely agree.
change their life.
So I think in this particular area, there's a lot of work that technology developers are doing. For instance, we are currently working with there's a National Rehabilitation University in Lucknow, where we are trying to develop some kind of smartphone apps, because I feel ultimately accessible technology is the only solution. So one thing that we can always try is we can try to provide these smartphone apps. I think smartphone is a great tool because already these are highly powerful devices. And if we can talk about some kind of real-time navigation, but the infrastructure is also mapped. For example, we know that there is a some kind of a footpath lack of a footpath in a particular area. That also should be updated in the navigation map. If we can develop these kind of digitized maps for movement and have smartphone based navigation, a lot many changes can be done. But again, it's a great point. I think from humanities point of view, from infrastructure point of view, technology point of view, I really hope all of us can work together and improve these concerns in the next couple of decades, because I think this is a significant concern. I myself have a lot of people that I know in my family circle who are having these disadvantages. I think it's a very urgent requirement for the country. Is there any other question?
There one more question in chat box from Sneha.
Yes, I can see that in the chat box. Neha has asked, "Hi, parking and mobility are interrelated. How AI will help in this aspect?" Yeah, again, great question. I did not really mention it in the discussion that I had, but one of the things that we can go for sustainable urban mobility planning is also predicting the parking spots in a city. So if we can actually tell that a user coming to a city can get a parking spot when they reach that point at a particular time in advance, those things will be game changing. And slowly, when we can reduce kind of the informal on street parking and have exclusive spaces for parking where prediction algorithms are there, I think it can completely change the mobility landscape in the country. And already there are some work in this direction as well. So AI is definitely for the prediction, Sneha. Yes. Thank you. Thank you, Sneha. So I think already we are close to the time. I think whatever question you have, if you want to send some of your students work with our lab, feel free to send your email to me. I'll be happy to reach out to all of you. And I hope we'll all get to meet sometime in person as well. So thank you. Thank you, everyone.
Thank you, sir. Thank you very much for enlightening session addressing critical aspects like intersection management, ticketing data, GFDS, predictive management, maintenance, smart ticketing and fare systems, and EV charging infrastructure, emission monitoring and management, assistant to eco driving. Your insights have offered a clear roadmap for sustainable urban mobility and innovative solutions in smart city development. So, thank you, sir. Thank you for sharing your experience and inspiring us. Thank you very much.
Thank you. Thank you, everyone. Thank you. I will leave now. Thank you. Thank you, everyone. We'll be in touch. Thank you.
So the the second expert, Professor Chetan Sharma, has joined this meeting. Professor Sharma, am I audible to you?
Yes, ma'am. Am I?
Yes, sir. Uh,
Thank you.
I'm heartily welcome to Dr. Chetan Sharma to this fourth session of this FDP. Dr. Sharma is a postdoctoral fellow at the University of Texas at San Antonio, USA, and a review editor for Frontier in Climate Research. He earned his PhD in civil engineering from the Indian Institute of Technology, Roorkee, India, specializing in climate change detection and adaptation strategies. With over 11 years of combined academic, research, and industrial experience, Dr. Sharma's work focuses on artificial intelligence, AI applications in hydrology, sustainable urban planning, and climate resilience. His research work contributions include AI-driven modeling for groundwater systems, urban water resource management, and predictive analytics for climate adaptation. He has published extensively in high-impact journals such as Nature Sustainability and Geoscience Frontiers, and and co-edited books on sustainable development and geospatial technologies. Dr. Sharma has led multiple research proposals and collaborate on NSF funded projects involving AI and data science in environmental modeling. He is an advocate of AI integration in smart city planning and has delivered invited talks on AI powered sustainability solutions. In this FTP, today he will discuss smart resource management AI in the circular economy. So, Mike is over to you, Dr. Sharma.
Yeah. So thank you, Kiran ma'am, for such a nice introductions and everything. I'm not that much great, but yeah, thank you for this. So um, I will just share my PPT, then we can just go ahead with this knowledge sharing. So just give me a moment.
Yes.
No, I'm not allowed to share my screen, so could you please let me?
Okay. Yes, sir. Yes, sir. Just a minute.
Yeah, thank you. Okay. So is my screen visible to everyone?
Yes, sir.
Okay. So good evening, everyone. For me, it is good morning, but yeah, good evening for everyone. So, and it's really my pleasure to be here and present my thoughts on this smart resource management and AI in the circular economy. So, everything have been told by Professor Kiran Booth about my experience in the research and everything. What am I doing? So, it is really pleasure for me to present my thoughts and everything in this FDP, which is AI powered urban futures advancing sustainability in smart cities, which is organized by JIT in collaboration with the ATAL. And so I just want to thank Professor Avinash Bora for his director of GIT and Professor Kiran Booth and Mr. Kamlesh Parihar for their coordination of this FDP. Also the Civil Engineering Department of GIT who have done a commendable job in organizing these events. Also the advisory board of GIT and above all, the enthusiasm of the participants in AI accessibility, so that you be so that you can learn a lot of things in the AI and the role in accessibility in the smart cities. So in next 1.5 hours, we are going to explore how AI is transforming the circular economy, how it can be efficient, how it can be useful, and um, what is going to be the challenges, and what the future is going to be. So, and this we'll have some questions, answers, and we can discuss and learn each together about this AI in the smart cities economy. So, yeah, so let's begin with this. So this is going to be the typical layout of my this presentation. So we are going to see and explore how the smart resource management uh, with AI in the circular economy. So first of all, we'll just try to learn what is the circular economy revolution, how it is going to be helpful in the sustainable design, sustainable cities, and everything. Then we are going to see how AI can help in this, and with the help in the waste management, the water treatment, energy efficiencies, and lots of things. And then how the AI can useful in the smart buildings designs and the smart grids and the smart materials, so that it can reshape the urban design. Then this presentation will be, participant oriented, so there'll be some interactive polls and the insights, so that you can also engage and you can just share thoughts, whatever you think about the AI, smart cities, everything. So it will be quite interactive. So please participate in those polls and everything. Then I will just discuss about the roadmap of the implementation, how to implement this AI powered solutions. So primarily this presentation is based on the lot of research papers and everything which I explored online, and which I am using in my research. So everything is backed up by some knowledge. So if you want the research paper, you can just contact me. I will just share it with you. Then ultimately we are going to see what are the going to be the future trends in 2030, like ethics in the AI, the governance, and the sustainability and everything. So coming to this, the introduction. So the circular economy. So what we generally do in our economy, like we just our economy based on the principle like take, make, and waste. Like we just take the things from the nature, we make the things like produce and everything, then we just use it, and whatever left over, it is getting wasted. So uh, the circular economy, it's different from this. It just what is do, it just close this loop. It just instead of take, make, waste, it just go from take, make, waste, recycle, reduce, reuse, and one more thing, the fourth thing, which I don't know you have heard it or not, but yeah, I will just share it with in my next slides. So yeah, there's a four things with the circular economy. There's the principles is there. So what the AI do, it just it just escalate our efficiency in taking the decisions, and doing the predictive analysis and everything. So it is very helpful to do the thing in the fast pace. So it can do the things like in the real time monitoring, the predictive analysis, optimizations, and like it just ultimately what does it do, it just save a lot of time, and it just help you to take some smart decisions in an effective way. So like we can use the AI in the material flow, recycling efficiency, reducing the waste, reorganizing things, smart or logistics, and everything. So there are a lot of things which can be helpful in the AI in the smart cities. So then right now most of cities are governed by the local authorities, or the the ministers and everything, the IAS, IPS, whatever things. Lot of authorities are there to manage the things. But ultimately, what is happening? The cities are a very large entity. So for a single person or a only small group of person, it is not effective to take the decision, because they don't know what is happening at a particular state of time and a particular place. So they if they try explaining, try just extracting this kind of data, so they will not be able to process and take the smart decisions. So how this is the role of AI. So it just take a lot of data in the real time, take the historical data, make the smart decisions, and it just let that these things are happening, and these things are going to be changed. So it help us to take the smart decisions. So it just ultimately help the concept of smart city is like we are going to reduce the things, we are going to have the minimum impact on environment, and we are going to be more resilient. So ultimately, this is the role of AI, to make the thing smarter, more efficient, save us time, and give us more and more choices to work effectively. So means this was the introduction template for you, but yeah, because the AI, a lot of things, a lot of people of you are using AI, but that is primarily the generative AI like ChatGPT and everything. So there means different kind of AI. So this is just a small poll. So I just want to have your means idea. What do you think about the AI? When anyone says the word AI, what is the first word which comes to your mind? So just you can just what you can do, you can just scan the QR code with your mobile and just type your word. So I will just keep it on for 2 minutes. So then I will see. Just type any word, single word, uh, whatever the word comes to your mind when you just hear AI. So please participate in this. So whatever you want to, AI, you can just think AI is a robot, or AI is a efficiency, AI is the whatever the thing you fear of the AI or ethics or whatever the thing comes in your mind. So please participate. Just scan the QR code, type your answer, and if you find any difficulty in scanning everything, please let me know. So please just scan it and just type it. So it will be anonymous, so the user's name is not going to be there. So please don't be afraid. So your name is not going to be there. So we are, slowly getting the answers like adding intelligence. Okay, that's nice. So please quickly. So we will have, more and more things that what the people think about AI. Anything, whatever comes in your mind. So AI is what? The artificial intelligence. No, means that intelligence is artificial. So just type anything so that we can just move our presentation. So the automation good. That's nice. Futuristics, everything good. That's nice. Okay, so still the things are positive for the AI, because I heard a lot of things which are people are okay. The futuristic have two. Okay, nice. More, please participate, then you will learn a lot about the things. Okay, yeah, yeah, artificial intelligence.
Uh, Good evening, Professor Chetan. We can also allow many participants to answer in the chat box message. Reason is that everyone might not be able to scan this QR code and run simultaneously Google Meet and slide to both. So some might
Yeah,
face
yeah,
technical limitations. So
yeah,
I would
you
request
can do
audience
it. Yeah,
to reply in the message also if you have. Professor Chetan will read your message also.
yeah, yeah, sure. You can scan this code with the anything with the camera app or anything, means because just scan with the camera you can do it. Otherwise you can just post in the chat box, then I will just read that. So yeah, intelligence, automation, transformative tool, revolutionary features. So no fear, nothing. You don't afraid of the AI. Means like that robot is going to take your word. No, no one is afraid of AI. That's good. That's quite optimistic. So this kind of environment means I have means a lot of uh, words. The thing which you come in your mind, these are primarily positive, and this is really a good thing for the AI, because in lot of cities and the scientists and the researchers and the people are against the AI. So like they have seen a lot of fiction movies. So yeah, but sometimes it can be true, but that's okay. So automation, transformer tool, revolutionary futuristic. Okay, this is good. Thank you. Thank you. So I'm just moving to my next slide. So you know a lot of
Anticipated
things about
intelligence
AI.
is also been replied. Anticipated intelligence is also replied by Pooja Mishra.
Thank you. And something negative, if you, someone have some negative about it, no? No fear? Okay, that's cool. So thank you. So now that shows that you are quite positive about the AI, and this is really good for our, advancement and adopting the AI in the smart cities and the circular economy. So means you are really optimistic about the AI and everything, and this is really a good thing for all of us. So now coming to the principles and benefits of circular economy. Uh, so I was telling that we know the three R's. Three R's are reduce, reuse, and recycle. But in the circular economy, there is a fourth R also. That is a recover. What is the recover? Like, ultimately, we just want to reduce our uh, uses. Fine. Then if we are not able to use it, then we are going to reuse it, then extend the life cycle of the product. Then ultimately, if we are not able to reuse it, then we just go to the recycle things, and we recycle them, convert into some different things, and just reuse them. But ultimately, some things are there like which are new, which are single use, we cannot be reduced, which cannot be reused and recycled. So they just go to landfill as a trash, and this is going to be contaminate our earth and everything. We are going to need a lot of landfills and everything. So what is the thing? That's a recover. Recover means ultimately the principle of circular economy is we are not going to leave anything on the earth unattended. Like if there is some waste, then we are going to convert that waste in the form of energy. Like there are a lot of waste to energy plants are happening there. So I think some means a very less efficient plant is there in New Delhi. But yeah, we also have in New Delhi, but the waste. If you have been to Delhi and you have seen to the wastage, the heap and the mountain of waste near the UP border. So yeah, that you don't like that. So that's really bad for the economy and the environment. So uh, I think that's a recover is the best thing. So what the AI do? AI do, it just optimize the flow of resources. It just optimize the, recovery of the materials, and it just reduce the waste generation, and it just tell you how much resource you are going to use, so that you just produce the resource which is required. So you don't produce a lot of resources. So what is going to happen? So it is going to have a lot of benefits. Like it is going to have the lower environment impact, because you're reducing the emissions, you are converting the uh, this ultimately the trash into the energy which is going to use for the clean environment. Then you will have, because you are having less resources, you are recycling everything, you are recovering everything, so there will be economic growth. And ultimately what is going to be AI is going to boost your efficiency. So that's the role of AI, to boost the efficiency, because uh, we humans have the limited capacity to do the task and gather the data and everything, and work on the data in the efficient manner. So we are good at taking the decisions. The means here the AI cannot beat us, but yeah, for giving it the points and the options, here the AI can help us. Now, I will just now switch my things to the applications of AI in some fields in the circular economy, like, the first of all, the predictive resource optimization. So, uh, uh, the thing, AI powered analytics can have the better resource prediction. Like, there is a miss I published recently papers in this nature sustainability, where I live in Texas, San Antonio. So this is generally a dry region, and we are having frequent droughts and everything. So here the government have decided to have some means its strategies, mitigation plans to reduce the use of water based on the water level. So I think they had that plan since 2006, but they don't know that the plan is going to be effective or not in the future, or whatever they have done it is having some effect on the optimizing resources or not. So the thing, we use the counterfactual AI, explained AI, and our study told them, okay, the things whatever we are doing have been useful in preventing the misuse of the water, and it is going to be really useful for the future. Means we have done some climate change scenarios up to in 2100, and if these measures have been used, then we are not going to face severe droughts which have already happened in the 1950s, 1960s. So the thing, we are really in this kind of technology, we can use the AI to know the things before it will really happen. So it is the counterfactual. Like we can have the things like, what if we do like this, and what is going to happen in the future if we take this decision now. So we are not going to wait till the 10 years, 15 years, 20 years to just see the effect of that decision. So we can have the decision, take the model, use the counterfactuals, and let us know that, okay, this decision is going to be effective or useful for the next 20, 30 years or not. So that's the help of the AI in predictive resource optimization. So we can have this resource in the what treatment plants and everything. We can develop the resilience against the environment shocks, and this can be also helpful in the smart urban planning, like when we are developing the smart cities, then where the resources should be allocated, or where the parking lot should be, or where should be the more greenery, or we how can we reduce the effect of urban heat islands. So this is thing like we can have the AI, and AI can tell us, if we have this plan, then this is going to be the future, and if we have this plan, this is going to be the future. So this is really fascinating to know the things beforehand, before going into any kind of deep hole there where we don't have anything to come out. So it can just tell you the things much ahead of the future. So that's the really good thing of the AI in the predictive resource optimization. So now the help of AI in the waste management. So waste, it is a really big thing and a big challenge for the country like our India, because we have a very very big population, and the people really don't just people just don't care the things about environment, just want to keep the things clean around them, but they don't see what are happening outside of the things. So it is not with all the people, but yeah, for me, most of people are fine, are doing good, and they just they have a concern about the environment. But the few people don't just think about me generating waste and their role in reducing the waste and everything. So that's a different kind of topic. So but yeah, so AI can be used in the waste management, like we like currently the government of India have I think 3 or 4 years back, or 5 years back, they have the waste sorting, like they are the Swachh Bharat Abhiyan, like they are having the moving vehicles where you can throw your house trash, everything. Say there is some dry and wet waste, so you have to separate your house waste into two bins and put them in a separate waste. So that was the real goal, that dry waste and wet waste should be separated, and dry waste can be used for recycling and generation of energy, and the wet waste can be used for the composting and a lot of other things, like producing methane and everything. So but you can see that how the people are not segregating their waste at their home. So they are just dumping everything in a single bag and just putting it everywhere. So that's the thing. So it is not really effective way, because people it is not the problem with the people. So it is sometimes it is a bit challenging to sort the things and know what is the dry waste, what is the soft wet waste and everything. So it can help us to enable the waste sorting and everything. So I'll just show you a small video. Means it is not very a big deal. So you can see a lot of DIY projects where the people have designed the AI tools to segregate the waste. So this is one. I just want to show you a video. It was posted on YouTube. I was really impressed with this. This is just a small design, and you can just separate the wet and dry waste with this. So just please see this. So, Miss, you see, this is not a very big thing to, you know, do these kind of things. So, it was designed with a DIY project from a student, and they were able to do it at their means with a very small thing. So, means the government have a lot of powers, and a lot of NGOs and a lot of things are there. So, who they have the power, resource, and everything, and they can use those kind of things to do the smart waste management, to reduce the landfill, and have the more and more energy generation, reduce the burden on the economy. So also the AI can be used for the predictive waste generation models, like, yeah, like every city, every house, every colony have the trends of waste generation, like this colony, like having a more kind of wet waste, and this kind of colony is having a more kind of like near the hospital we have more medical waste. In the colonies, like where general people live, there will be more kind of wet waste. So we have, so in the and people are coming, and economy is growing, and population is growing also. We can have the predictive waste generation model, so it can tell you that in after 10 years or 20 years how much is going to be the waste in this colony or in this city. So we can have uh, proper management of the waste that is going to be generated after 10 years. So the thing, you can have beforehand models and everything, and the quantity required to segregate that waste, and everything. So this is based on a case study, so in which the some AI models were able to have more than 90% of achieving sorting of accuracy in the recycle plants, and which also help us to improve the material recovery, because as soon as you have the waste in the landfills or whatever the recycle plants there, so as quickly you just segregate them in different components, it is very useful to have them recover, to recycle them. So some things are not actually broken, so you can recycle them in some different materials, and it just will reduce the effect on the landfills, and you are not going to convert them into the burn them and convert them into the energy. So you are going to, so as soon as you have the trash and the everything, so I heard a sound. So is there something? Okay, sorry. So you can have smart recycling thing with the AI. Now, for the AI in the water resource management, so we can have the AI powered monitoring systems, like we can have the thing. AI, what does the AI need? AI need the data. So data is like we are collecting the data of water resources and the weather and the cities, and like population data, everything, whatever we are for having the data. A lot of data we are having in the form of charts, table, on the papers, on our Excel sheet, and everything. So data is not in the problem with us. And so the thing, you need to train the data and have the assessment of have the historical patterns of data, and the basis of historical patterns you can have the assessment on the water quality, or the levels, or the distribution networks, or the energy, or anything. So uh, if you want, means AI need a lot of data. So if you want that data, you can have a smart sensors and everything, and get the data, train your model, and just have your means predictions ready. So that's really easy to do the thing. So so in the AI, we can have, you have like I have heard in a newspaper, like in some cities in India, there are more. There is going to be there is more than 30% of the wastage of the water because of the leakage in the distribution systems. So, whatever the AI can do, AI can do because of smart center is the smart sensors and everything. You can have the detection of leakage and everything, so that the water wastage is going to be um, um, minimized. And there was a case study in which means we were able to predict the droughts and everything, and we were able to improve the recharge strategies to have the more water in the coming future because the population is growing and everything. And we can also have the enhanced water treatment based on the data which is real time, also historical. So yeah, in the water resources, the what means AI can be quite effective. Now, for the smart energy, energy means every kind of energy is what, like the electricity or the heat or whatever things are there. So AI is pretty good in forecasting. So if you have a good amount of data and you have the population, because population that demand increases, so you have the demand patterns and everything. So we can integrate the demand and the future demand, historical patterns, everything, and we can supply this to the AI, and we can have the very good forecast that what is going to be and its demand in the coming future. So, looking for the trends with the India, so population is increasing at a very fast pace. Means we have exceeded the China. So ultimately, the resources are not infinite, but population is increasing infinitely. So means there is no curtailment on the, but resources whatever we are taking from the earth, they are limited. So India is having very limited resources. So uh, um, the thing, ultimately we should know what is going to be the energy demand. So how we are going to meet the energy demand of the public, which is going to be here in the year 2030 or 2050. So we need the AI. That's need R to have the energy forecasting, because if you don't forecast uh, energy demand, we will not be able to have the proper management and proper plans to mitigate and adapt then, and help the people. Otherwise the energy is going to be increase and increase and increase, and if we are not going to supply energy, the economy will go down. So that will be really bad for any country or any society. So there have been a lot of case studies in which the AI have been used to improve the grid stability. Like in the year I think 2010 or 2012, we heard that our northern grid have been failed, and the whole northern India was in dark. So so for the grid stability and to reduce the energy losses, the AI is really effective. And there were research paper by Verma et al. So it have been seen that AI can enhance the efficiency of the grids by 15-20%. So 15-20% is a lot. So you are losing 15-20% of the energy in terms of per transmission losses or the theft or everything. So we can improve the uh, higher energy and everything. So now, also the AI can be used in the recycling and the material recovery. So, like I earlier told you that AI can be used in the AI-powered sorting. Like I show you video, but that was really a small kind of thing with a DIY and just made by student. But it is being happened in a lot bigger way in some countries. So in some countries like Germany and then Norway, they are using the AI powered robots which are helping to segregate the waste in different components. So they are means in the Norway, what they are happening, these AI robots, what they are doing, they are sorting their uh, waste into different components. So whatever can be recycled, whatever can be converted plastic or glasses or tin or paper, and what is going to be as a trash for the landfills, and that can be used for the energy generation. So the Norway is helpful, is now doing a lot in the things of AI driven robotic sorting systems. So they are able to increase the recycling efficiency by 40%. Means that earlier they were whatever they were recycling, they are now able to improve the recycling by more than 40%. So which is, which is very big thing. So they are ultimately reducing the landfill contribution by 40%. So that's a very big amount. So if you see the very heap of the landfills and in Delhi and everywhere, so that can be reduced significantly. So if you use the AI powered sorting, so this is the one of the big thing for means to reduce the pollution, contamination, everything in the big cities. So now in the urban resource planning and analytics, we can have the AI, like AI driven urban design tools, like we can have the smart urban planning, which can simulate the infrastructure needs, and it can optimize land use. Like I was in the in the presentation of Dr. Agnivesh before this. So some people are asking about the transportation and the parking and everything. So yeah, smart cities, circular economy, economy covers everything. So with the help of AI, you can have smart cities planning, like where you should have the parking lot, where should you have the more green areas, where you should have wider roads, or where you are going to means where your traffic is getting congested, or where you need the more energy demand. So these are things like AI driven tools uh, can help you have a better decision of the planning of any city, or the challenges being faced by any city right now, and take the better decisions. And we can also have the better models to predict the to predict that where the resource should be allocated first. Like we have limited resources in a we have limited resources. So, and like let's say 10 cities need the same resources, but because of the AI, we can know that which city or which locality need this first, and which can wait for the for later. So like in the case of emergency, like the COVID happened. So COVID cases were coming from everywhere and everything. So in the case to prevent the spread of the COVID, and keep the people isolated, everything, we could have the AI power system, which can help you to decide that okay, this city need more urgent care than other cities. So you can have this kind of decisions to have the prediction and forecasting of the your decisions. So there was a case history of the AI in the smart cities. So what is happening, like in the Singapore, Singapore is doing a lot in the AI and smart. They are doing very big investment in the AI and smart cities and everything. So they are using AI in the smart traffic management. So they have reduced their traffic congestion by more than 20%. So traffic congestion is very big uh, challenge in India. Whenever you go to Delhi, or even in the Jodhpur or the big cities, the traffic in the peak time, office hours, on the evening time, you see a lot of traffic and everything. So because of AI, we can have reduced traffic congestion. And also like we can have the better energy consumption plan, like the Barcelona, it have adopted the better resource allocation, like from the smart grids. So in the smart cities, smart grids, we can have the better resource allocation, and may reduce the energy consumption, may reduce a lot of things like wastage, traffic congestions, and everything. So there are a lot of things which AI can do. Now, the thing, like AI in the predictive maintenance and the resource tracking side. Uh, the thing we have now, we have the produce, we have the factories and everything. We have the ACs in our houses, or the heaters, or the water motors, or there are factories which have a lot of equipments, and energy. The power plants are there. They have a lot of things, and if it something goes down, then it is going to impact a lot of things to us. Like if the like the smart grids went down, so the whole North India faced a lot of things. Means there was no power in the hospitals and the schools and everything. So like AI can do a lot of things in the predictive maintenance, like it can forecast the equipment failures, and it can prevent a lot of big maintenance issue, and save a lot of time and resources by just telling you beforehand that this equipment or this system or this sensor is going to be fail in this much time, so and you need to change it. Like in your cars you have a smart monitoring like sensors are there. We just tell you, okay, now your oil is going to be need to be changed. So what is it? It is telling you that this oil or this now we have the tire pressure sensors also in our car. So you just they tell you, okay, the tire pressure is low, so please get it inflated and everything, so that your vehicle don't face any troubles. So this is not, that is not AI, but yeah, that's those sensors and everything, that's the source of data to the AI. So that data can be used in in better predictive performance, and can help us to prevent the complete failure of an equipment. And uh, so and we can also save a lot on the repair cost. And we can have also the real-time resource tracking, like we have the sensor, like so you in the company, what we do, we just plan a project, and we just allocate the resources, but the resources actually going in the way which we thought or not. So the resource flow can be tracked with the AI, like from the IoT and the machine learning, and you can see how the things are going on, like the supply chain. And like some people like in some resource, like like if a construction activity is happening, and there you have 5 trucks and 4 trucks are working, one truck is being idle. So that is a waste of resources. So you can do the even track it like the smart sensor, that which how number of trucks you needed, and how many trucks are being used, which one is getting idle, so you can use it to other place. So that's a very good, and the real time resource tracking. So there was a case study in the smart water management, where in the AI was used to lower the failure of pipeline, and they were able to reduce the pipeline failures by 40% by having the real time monitoring. So you sometimes you see in your houses also, which are getting the tap water, that tomorrow from 8 to 10 or 8 to 12, or for the whole day, the water is going to be shut off for the maintenance and everything. So generally what we see, when the water, and we see a lot of water getting wastage on the, some pipeline get burst and everything, and people, and NCD guys, and they take a lot of time because of their engagement in other activities to repair them, and it just wastes a lot of time, lot of resources. So with the help of AI, you can, in the smart cities, in the circular economy, what you can do, you can just reduce the pipeline failures. Also in, in the pipeline failures in the oil refineries, and in the fertilizers factories. So you can, optimize the uh, you can have the AI in real time monitoring to reduce the pipeline failure. Also in the waste collection route, you can reduce the cost by the fuel by 15% by just preventing, the idle or resource or everything. So you can see that AI is having a lot of applications in our day-to-day life, and in the smart cities, and to reduce the waste and everything. So now I will have a one more poll, that uh, uh, like to just know your knowledge, how much do you learn, or how do you know that which AI feature do you think contributes most of the predictive maintenance, like uh, data analysis, IoT sensors, machine learning, and all, like what data analytics do. It just, we have the data, we analyze the data and make the models and everything. IoT sensor, what does it do? It just, IoT sensor is internet of things. So you have the sensors, it is connected with the internet, so it just gives the real-time data to your machines, or the programs, or the applications. And machine learning algorithm, what does it do? You just have the data, you have the sensor, you just get data from IoT sensors, and you have the programs, you have the apps, you made them, and tune them for your means for your application. then it just give you some predictions or some forecast. So you can just scan the QR code and tell us that how which thing you think is most important in the predictive maintenance, like data analytics, okay, machine learning, good, IoT, all of them. So okay, sure, okay, data analytics. People are thinking data analysis is more. Okay, so all of the above, good. So means for you, which is the best, which is the most important part of any model or any AI technology? That's the data, or the people who have the algorithm who design the things. So the data is useful more. Having more weightage, or the analytic who do the data computations and do the prediction modelings and everything. Okay, so now people are understanding. That's good that you are getting a lot of uh, enthusiasm, and you have big good knowledge of how the AI works. So okay, that's good. So IoT sensors means without the sensors, I don't know how you are going to train your models. So you need the sensors to have the data. So without the data, yeah, ultimately, yeah, you might have uh, past data also to train your model. But in the real-time monitoring, IoT sensors are required. But yeah, that is not a very big thing. IoT sensors, that's good. The data analytics and machine learning, fine. So that's good. Means you have again a lot of knowledge in AI and the maintenance. So I really like it. So yeah, IoT sensors is that's really good. That IoT sensors are not that much useful because we might have a lot of historical data to train our models. But yeah, IoT sensors would be required if we want the real time monitoring. We need the real time data. So we cannot just hire a person to just give us the data sitting at the site ideally. So that's not really practical everywhere. So nowadays, IoT sensors are having a very big job, and the shortage of chip and everything, it is going to be having big impact on these sensors and everything. So that's a big kind of deal. So yeah, thank you for sharing your thoughts in this. So yeah, you have gained a lot, miss you who already have a lot of knowledge about these things. Thank you. So AI in the time data governance and decision making. So now we have everything. We have the data, we have the machine learning, everything. But ultimately, the thing, the researchers or the companies or everything, they are not going to have the authority to take the decisions. So ultimately, what they are doing, they can just tell the authorities or the government to have these kind of that this is going to feature, and if we adopt these kind of measures, then this is going to the impact. We can just the researchers and the companies, everything, they can just tell this, that this is going to feature. But ultimately, the government and everything, they have the power of decision making. So if the government is not smart, but your AI is smart, then you will not be able to have those decisions happen in the real time, because in the government there is no one to understand those kind of things in the systems. So whatever is happening there in the system, in the AI, and you are doing high tech designing, you are doing AI predictive modeling, you are telling them, okay, this is going to be happen, this is bad, this is good, but there is no one in the government who is going to take the decision or who is able to understand your things. So that would be a really big challenge. So in so many countries, the government is having a separate AI department who can understand the things, who can use the AI and everything to have a better decision making and better understanding of the system, the challenges with this, and have their more impactful and efficient decisions in the smart cities or the economy. So the AI driven data governance, what does it do? It just it just help you to classify the data. It gains you access control, because in the big countries and the big cities, you have lot of data from the people, their behavior, their driving experience, their habits, their routes, and their energy uses, their food habits, their wastage cycle. There are lot of things are there. And people are coming, the population is growing, some immigration is there, the people are coming from the city and going, leaving the cities and relocating to other cities. So there are a lot of government have to decide that. And a single person cannot have that much data, and don't have that much power to take the decision based on that amount of data. So in that case, uh, you need the AI in the governance. So recently, the US, the term government, they have a separate department. They have separate department for AI, and there is an Indian guy who is now heading that AI department in the government. So also. In the Singapore, they have the AI powered decision platforms. Also, Barcelona have AI data government system. So if because AI is the future, if you don't use this, then you are going to be lag behind in a lot of things. So what is sustainability? Means use the AI sources to maintain the resilient environment, and use the resource sustainably, and have less and less impact on the environment. So that's the thing. So because you have a lot of data, a lot of people, a lot of things, resources, energy, and humans are not capable of doing that kind of analysis. We are good. I'm again repeating, like humans are good in taking the decisions, but analysis is not, is out of the capacity of the humans, because we cannot process that amount of big data in a go. So we need some machines to have that uh, have the data analyzed, and training, and do the predictions and the forecasting. So in the government also, we need some resources, some people like that who understand the AI, and they can help us to they can help the government to take the effective decisions based on the AI. Because otherwise, if the government is not taking initiative in the AI, then the whole system will collapse, because that's the demand of the future. So other countries are using the AI and everything, we are not using, we will lag behind. So that's the simple thing. So we have to use this AI in the governments. So and it's so a lot of there are a lot of studies, like Singapore is using this AI powered digital platform. So they have reduced their emergency response time by 30%. Like they have, because that's a coastal country, so there are a lot of things like floods and everything happen. So they have reduced their decision response time by 30% because of AI. Also, in the cyber security, threat detection, like anomalies, and intervention in some kind of bad things, you need the AI, because you cannot just track everything visually or just seeing the trends. You need the AI to track your economy, your money, your governments, your means threats and everything. Now coming for this, like for the buildings, how can AI be helpful in the sustainable building design? So sustainable building design. So what is sustainable building design? Like how can AI use it? AI can help, because as the climate change and everything is happening, we are having more and more extreme heat waves, more and more extreme floods, more and more extreme droughts, more and more extreme heat, cold waves and everything. So so we have to be ready for the future. So ultimately, if we use the AI, so it can help us to minimize the energy cost to design the building such that we don't have to use a lot of energy in heating and cooling and the lighting, and getting the data from the building, and ultimately having the net zero building. Net zero is what? Ultimately, whatever you are energy or energy you are taking from the environment, you are producing the same amount back to the environment. So ultimately, you are having net zero impact on the environment. So that's called the smart building. So in the smart building, you but based on the locality or the city or the area or geography or your weather, you can have different kind of materials which are sustainable, smart enough to reduce your carbon footprint, and it can also help you to predict the performance of material in certain localities. So it can also tell you like which kind of material would be helpful in your building, so that you have less amount of wastage, and there will be better recyclability of the material, and ultimately that is going to be having a positive impact on the project. Like it will reduce the wastage, it will improve the efficiency, it will reduce the cost. So there are a lot of things which are going to be helpful if we have the AI for sustainable building design. So people are already using these kind of things, like in hot areas like in the Rajasthan outer part, like that they are having the stone, most of the stone building, the stones are very thick, and they can they can withstand the high amount of temperature, and sudden freezing and sudden thawing temperature, like that. So they are already, because of their experience, the people are adopting that kind of material. But these things are not going to be sustained because of climate change and everything. A lot of things are changing. So we need the AI to help the people know that okay, you are going to make a home or a building or an industry, and that's going to be last for more than 40-50 years. So the trend which is going to be adopted now, it is not going to sustain in the next 30-40 years. So you need at least miss some idea of the future, so that your buildings and your cities or your industry could be sustainable, and it can withstand the impact of the environment and everything. So now in the Dubai, the Emirates and the Saudi, they are doing a lot in the to advance their cities and everything. You have seen a lot of wonders in the UAE and everything. So they are using their Dubai Smart City project. They are using AI to enable the designs, like architecture and the type of material, everything, and they have reduced their energy by more than 25% by dynamic control of the lighting and HVAC units and everything. And you can minimize the construction waste by using these kind of things in your building design and architecture and everything. So if you want your buildings to be future ready and buildings to be smart, you have to integrate the AI powered smart sensors and everything to, and occupancy or any hazardous condition, like you should have IoT sensors in the building, and the sensors can tell you, or they can just automatically switch on or switch off for the fire protection, for the for turning the light on and off, and means turning on or off the HVAC systems, or whatever the things are. There are a lot of applications which can be used to minimize the energy and improve the cost. So it is being means adopted by a lot of countries nowadays, and a lot of cities. So like in India, means we also have a lot of smart cities and everything, and they are going to properly planned. And but yeah, we I don't think that they have been backed up with the information given by the AI. So I hope that in the future the AI is used to take the better decisions, that okay, this is smart city, like city in Rajasthan, or city in the Tamil Nadu, or city in the northeast, or in other part of India, that because every city is having a different kind of demands and needs, and the weather and population and the history. So you need separate solutions for each smart city. You can have a single solution and apply to all. You cannot do that. So you need AI to have the smart buildings, smart cities, to do their things for the long-term sustainability. So now in the how the AI can be effective in environmental monitoring and disaster management. So this is the thing which I think you guys lot of have idea, because you know uh, like if we just if we just think about like 50 or 100 or 60 years back, like there are a lot of cyclones or typhoons are happening in the coastal areas in India. So if we think that a cyclone, or if a big cyclone, like I think in 2014, 2014 there was a big cyclone in Tamil Nadu, and people were evacuated in that time, before time, so that the government was able to save their lives. So what happens? We are having the weather sensor, we are having satellite, we are monitoring data. So what is happening? So the government is able to, the people are able to tell you beforehand, before days, 10 days, 15 days, okay, the things are going to be bad in this area, so people need to be relocated, so that we can save the lives. But if this was not, this thing was not before 50, 60 years, so whatever the cyclone was happening, the people just came to know based on their past experience. Fine. And only by means only only half day or few hours they might have to just save their lives. But now the people, because of, we have a lot of data, we have the AI, we have the models, so we are able to see the things much ahead of time, and we can save the life, we can save the resources, and everything. So the AI is very helpful in the environmental monitoring, because we have the satellites, we can have the remote sensors, and we can track the pollution levels, we can track the soil health, we can track the weather changes and everything. So we can have faster interventions to minimize the impact of the changes in the environment, or any disaster which is going to happen in that certain area. So AI is very helpful in the disaster management and predictions. So like I told you, like in the cyclone, in the typhoon, or the flood, or in the tsunamis, you have early flood or tsunami warning, so people are asked not to go to the sea, or just relocate themselves from the much away from the sea source and everything. So means we have a lot of things to do, like we have few research papers, like people are generally able to, now people are usually able to predict the flood more in more than 90% of cases in the Ganges basin in India. Also the Singapore, which have used the AI to reduce the response time by 30% in the emergency coordination. So these AI technologies help us to not only safeguard the lives, but also minimize the resource losses, and also AI have the role in the disaster prevention, and it is a transformative tool to have the climate resilience and the sustainability. So ultimately the goal of the AI and everything is the sustainability, the how you are going to sustain in the ever-changing climate, and the population and everything. So ultimately we have to sustain. If we don't, then the societies are going to be collapsed. So now the AI and the circular economy in the material recovery system, like I discussed in the earlier slide, that how the AI in the robotic sorting systems can have the early recovery of the things, so that you can recover whatever you can and reuse it and recycle it. So AI can be used for the material sorting, like recycling, to increase the recycling efficiency. So you have the neural networks, like convolution neural networks and ANN. A lot of image processing softwares are there, which which can just look at the waste and everything, and it can tell you that how much waste is going to be the recyclable, what is going to be the trash, and to be used for the energy, how much is the metal, how much the plastic and glass. So look, in the US, what the system we have for the wastage from the house, we have recyclable materials and the non-recyclable materials. So the recyclable materials are the metals, plastic, and the glasses. So we have the two kind of bins. Like India, we have wet and dry, but we have the recyclable and non-recyclable. So non-recyclable goes for the trash, and the recyclable comes in the metal, plastic, paper, glasses, and everything. So that goes for the recycle bins, and it goes for the recycling. So the thing, in the India, we have a lot of populations, a lot of public is there, so it is a bit challenging to have people understand the need of segregate the things in the uh, recyclable and non-recyclable. So we should adopt the AI for the faster and more efficient processing of the things. Like like the people generally, what is happening in lot of places, like you see you see few people collecting the trash from the roads or from the landfills, everything. They are collecting the plastic and the glasses and everything. What they are doing, they are just taking your waste and they are just segregating it and they are recycling that. But this is very highly ineffective, and means need lot of labor, lot of time and resources. So it is not really efficient to do it at a very large level. So you can have the AI to have the sorting machines, sorting materials, and people have achieved very high accuracy in sorting. And you can have the smart recyclable process, like you have algorithm to optimize the material flows, and based on demand, like whatever the demand, you have predicted the demand, like this is going to demand in next hour or next year or next week. So you are going to produce the resource such that is going to be effective for that demand only. So you are not going to overproducing things. So you are ultimately, what is doing, you are reducing your production, so you are reducing your landfill waste. So we have a lot of case studies, lot of papers have been published in the AI in the plastic recycling, like we have like in the Germany, they have the some plastic disposal AI robots, means plastic segregating. So they have reduced the disposal cost by 25%, and they are using that recycled plastic to make new things. And also, like AI can be very useful in detecting the contamination detection. Like whenever you have the landfills, it is going to contaminate the earth and the groundwater. So you should have the sensors, like IoT sensors, everything. So it can tell you that this is going to be this area is going to be contaminated within 30 to 40 months, or within a year, these things. So you need to do something. So uh, we just really need the things in our country which have a lot of challenges of waste, means management and everything, to have the AI in our system. So now the AI in the circular design and manufacturing. So what is circular design? Circular design is what you are not going to waste anything. Means you are going to produce, you are going to use that, you are going to recycle that, and ultimately, if you are not going to recycle that, you are going to recover it in the form of energy. So AI can be very helpful to design any product sustainably. So so AI is now reshaping the product design and manufacturing by integrating the circular economy principle, that is the 4R, that's reduce, reuse, recycle, and the recover. So how we can do this? We can we can use the incorporate the AI in the from the inception, like from the selection of material to the life cycle assessment, like how much is going to life of the product, and then its durability, then it is going to be recyclable or not. And if it is not, then it is going to be going for the recovery, like for the energy generation and everything. So it is very useful in the green manufacturing, like you are not going to have a very high environmental impact of that material or product on the environment. So it is very useful in the workflow automations, and you can also track the resources. You can also do a lot of things automatically, like in the Japan. Japan is also doing a lot of things in the uh, AI and technology and everything. So they are able to reduce the waste by more than 30% by optimizing their workflow. Workflow, like whatever is getting produced, recycle, recover, everything. So they are going to means they are able to reduce their waste by more than 30%. So, and also their energy have been improved by more than 20%, because ultimately, if you generate less waste, then you are going to save the energy. Because waste generation, waste is because you are going to have some resources to generate that product which is going to be wasted. So ultimately, if you are reducing the waste, that's mean you are reducing your cost in generating unnecessary product. So that's how the AI can be useful to tell you beforehand that this resource or this product is to be of this type, and this is the going to be demand of this thing. So just produce that much of this product only, that is required. So you are not going to have to store it, or you aren't going to overuse it, or you aren't going to uh, have that in the landfill ultimately. So now I just want to discuss about the AI in the supply chain optimization. Supply chain optimization. So what is supply chain? So supply chain means you are having this. You don't grow everything in your house. Like, if you eat the food, then food just comes from the farms. The people just, from farmers, just grow the grains and the food and everything. They just cut it and just send it to some dealers, and they just they pack them and just send them to the big markets, and from the market it just go to small shops, and everything from there you buy, you just cook it and make it. So that's a supply chain. Like, you have the demand, and there are people who are going to fulfill your demand. So but what is happening, if you there is very small uh, um, um, means that supply chain is not effective ultimately, because the people who is growing, the farmer who is growing the wheat or everything in their farms, he doesn't know what is going to be demand in the next year. So you see, in the lot of years, we have seen suddenly the price of onion is going to be skyrocketed, and sometimes price of garlic is going to be even the 50 pesos per kilo and everything. So it is really really so challenging. Like, the farmers are doing a lot of work and everything, and they don't know, because in certain area they just start growing, because of, like, see what happens, like onion. Like, this year the price of onion are going to be very high. So what happens next year? The farmers or everyone, they think that, okay, the next year, to have the more profit, most of the people, farmer, they just grow the more onion. So next year you have more onion, you have more supply, but it's less demand. So what is happening? So there is not optimization of the supply chain. You are having, if you are having more demand and less supply, the cost will rise. If you have less demand, more supply, the cost will go, but it is very bad for your environment, economy, and the sustainability. So is that's the thing which you need the AI in optimizing the supply chain management. Like, it you can have the planning of inventory, what it even is, material or the resources or the food or whatever things are here. And also there is thing like you can have the reverse material flows. Like, okay, if you don't know that you have produced higher and the demand was lower, then you can have the reverse material flow. Like, you can use the same material, get back to the factory, and produce again. So it cannot, you can do it with certain material, like in the food which are perishable, so you can do that. But yeah, for most of the things which are non-perishable, you can do that in the circular system. So you need, it, so the AI in the supply chain, it just reduce the overproductions, and it also used to automate logistics. Like some, like you are like, the product is being made at some place, and it is transported to the place at 1,000 miles ahead, and you have to travel in that from in the trains or in the ships, or means the and the trucks and everything, ultimately just reach to your doorstep. So you don't means ultimately, if you produce higher than the demand, then you are having more logistics to transport the material to your doorstep. But ultimately, that is a more, and you are not going to use it. So that's the means not efficient use of the logistics. So in the for the with the AI, you can, what you can do, you can have the AI to have the smart logistics optimization. Like, have the smart management of the resources, have a smart knowledge that, okay, this much resources are required to transport that material to that factory or that market, and save the cost. So there have been a lot of studies like this in the like there is a study which just tell us that we have that people have just decreased their 25% waste through the AI driven logistic models, and also because of the reverse logistics and heavy recycling everything. So the people are really able to collect, sort, and return the the material which is recyclable to the factories again, so that it can be reproduced. So it is really very impactful for the circular economy and having sustainable supply chains. So let me check the time. Okay, 15 minutes more. So so now the AI in the I will go a bit faster because I still have the 10 slides. So 15 minutes, fine. So AI in the predictive analysis for waste and water management. So waste management, we have seen a lot of things like how the AI can be used to minimize the waste by helping to produce the less material and as per the demand, and also recycle that, also have the dynamic scheduling for the waste collection, and have the sorting the routes, like which route is better for transport the things, and identify the cities or the locations where the demand is going to be higher and supply there more, and where the demand is going to be lower, supply there less. So ultimately uh, have the management of the demand and supply and keep the inflation within the limits, and ultimately it is going to have means produce lesser waste and better and efficient model. And also in the water management also, like the waste and the water management also, like AI is able to forecast the demand of the water, like from the public, with the people coming to new cities, the relocation and everything. And sometime in the summers the demand of water is higher, in the winter is lower, or within the day, in the morning time when the people just go to office, and when the kids go to school, the demand is higher, and in the evening when the people return from their job, the demand is higher. In the night it is very low. So, and but in certain areas where we have the night shift or industries are there, their water demand might be higher in the night. So you can have the AI in the water demand pattern analysis, and you can have better models to optimize the resources. And also I have already told you that how it is impactful in uh, reducing the leaks, and reducing the uh, uh, missing or misuse, or the wastage of the oil or the water or everything in the urban network. So there was a study in the California, like it is what is happening in California. They are having the AI enabled leak detection systems to reduce the water losses. So they have reported their results, and they have seen that they have saved more than 12% of their waters. So that's a millions of gallons of the water they are saving because of AI systems annually. And Germany, they are having the better waste collection routes, and they are having they're saving more than 18% in their cost by cutting the fuel consumption, and saving the fuel, saving the energy. So because of using the AI, you can have impact. You just know beforehand what is going to be the extreme weather, or how much is there going to be demand, and how much is going to be supply. So you can have better management and better decisions to take on the data and on the models. So now coming to this, the AI machine learning for the circular economy matrices. So the matrices, like how do you check that AI performance is doing something for you or not? So that's for the decision making. So what the AI do? So we can monitor the material flows. We can have the continuous improvement in our systems because of the continuous feedbacks, and we can have the monitor material flows. We can have the monitor the recycle rates, and we can monitor the energy consumptions. So it will be really useful that whatever decision you have been taken, so we have real-time sensor that it can tell you that decisions have been taken, and this is going to be impactful, or this is useful or not. And if it's not, then you can have other decisions, or just slight change your policy and just have and revise it again and again. So it is very easy to do. So uh, there are a lot of examples, like in the Amsterdam and everything. They are able to reduce the CO2 emissions by more than 30%. Like we have the COP and everything. They have the plans for 2050 that we have to reduce the carbon emission by this. So if we don't reduce our wastage and everything, and if we don't adopt for the circular economy, then we are not going to meet our those goals for 2050 and everything. So the we need that for sustainability of our systems, and to forecast our future sustainability performance, and to meet the global standards, and that is really required for the sustainability and our profitability. Ultimately, whichever this requires for is required by any society or any country. So now we have just discussed a lot of things about the AI and everything, but what are the barriers and challenges? Because why we are not able to, adopt it? So first of all, the thing is data privacy and the security concerns. So, ultimately the data is the backbone of any AI product. So if you, what is data? We are providing the data to the people. So ultimately, we are giving the data, our day-to-day patterns, our routes, our traffics, our resources, our habits, everything. So our means data transactions, our economy. So whatever the things is there, that's a data. So data is sensitive. So it might be sometimes challenging to maintain the security and the data privacy, so which this is a very big concern. Also, the cost of AI implementation is very, very high in sometimes, because AI is a new technology and you need a lot of sensors and tools, infrastructure, and means you really need skilled workforce to operate this AI tools and everything. Otherwise, you have the better tools, but you don't have a skilled workforce, you are not going to get a good results, because there should be people who understand the options or the decisions made by the AI, that it should be adopted or not. Then the scalability and the integration challenge, like we in our country, India. So there are very big number of cities which infrastructure is not really supportive for the AI integration. Like the old buildings, we cannot have the sensors, everything, and we cannot. The country is very large. We have a lot of population. Country is big, and big cities, everything. So the scalability of AI in the developing regions like us, it is very big challenge. And also the ethical and regular barriers, like the ethics is the thing which is really complicated to understand, like how to make the system transparent in the decision making. And and there are always some biases in the AI algorithm, because they are the people who are having the AI system, and they are using and making decisions. So there might be someone or some people or some agencies who want to have the advantage of that AI. So they can ask you, they can just give you the options which are only good for them, and you might think that this is good for the public. But ultimately this comes on the ethics, like it is good or bad for the system. So this is these four barriers I have included in the presentation, but there are a lot more, but these four are prime barriers which are you really preventing us to apply the AI in the full mode. So now, coming to this, like AI trends and the future innovations, like the lot of the AI technologies, like explainable AI and counterfactual AI and the edge AI. So they are really good technology, advanced technology for having the transparent decision making. Like what do you do with the explainable AI? So in the AI, you can see that which factors are really useful in having that decision. So means this is so simple and so easy that even the the people who are just literate, they can understand, okay, this factor have been contributed more for this decision, so they can just see and understand. And like in the edge AI, so they can have the real-time monitoring and the remote locations. So these are emerging data. There are a lot of others, and like the AI enabled circular platforms, like we have the cloud based, like cloud-based platform which have the supply chain data, and we can have the end-to-end traceability, and we have the blockchain-backed AI, like the blockchain, whatever you just hear the term blockchain, you just see that there's a cryptocurrency. No, blockchain is being used in a lot of data sharing platforms, and from the banking agencies and everything. So, and AI also helpful in the smart material innovations, like we can have the better materials for our designing in the smart cities and the buildings. We can have better biodegradable materials, and we have the self-healing concrete and everything. And I was reading a research paper in the ASE journal, that with the help of AI, they are able to produce more than 1,000 variants of the concrete, which is sustainable and better for the circular economy. So you can do this, but it is not true that all hundreds are good. But yeah, you have the options of 100. You can test them in the lab, and you can decide that whichever is better for you, for the accessibility or for the society. So yeah, it is giving you the options to have more research on certain areas. So there are a lot of research papers. You must go on the scholar or the any referencing material tools to have how the AI is useful in the enhancing the smart grids efficiency improvement, and integration of renewable energy and everything. So there are a lot of things you can just go online and check. So now the AI in the policy frameworks and regulations. So means ultimately, the government is that who have to take the decision. So and there are some policies, some regulations are there in certain countries like GDPR in the Europe, and AI Act and everything. But I really I'm not sure if something is there in India for this AI implementation. But yeah, I hope it will soon be there. So if we want to implement the AI in our governments, then there should be some policy which held the accountability of the government and the public if we use the AI in that. So there should be some regulations in the circular economy who which ensure the transparency, fairness, and privacy protections in the smart city projects, like that. Like the like Europe, they have the Green Deal. In this, they have mandated the AI Act to the trustworthy AI systems. But the thing, ultimately, it comes to the ethics. So the people who are in the government, who are designing or who are applying these things, how is their their need, or whatever they want, how whatever their ethics are. So if they are doing everything in the for the help of the general people and for the country, then this is really good tool. And if they are not, then they can just mold the AI in their favor only. So ultimately there is a challenge with the ethics, and we cannot just say that AI is going to be good or bad. It ultimately, it is we, the people, who are going to apply these AI. So this is I think this is the last poll. So you can just scan the QR code and just tell me whatever you think, which AI regulation is require the most focus in your opinion. So just scan it and just share your views, that whatever is the biggest concern for you in application of AI in your country or your area. And you should generally should not afraid of the AI, that they are going to collect your data. You are already giving a lot of data to these companies like Google or the Android phones, or in the Apple or anything. Like you are, every time you are just scanning your biometrics, you are scanning your face, you are having the Fitbit watches and everything. It is tracking your whole activities, your body patterns, your biology, and your tracking their routes and everything. So just don't worry, you are already using a lot more AI in your life than this the government can do. So means this is not a thing to get afraid, because uh, even before AI, there were a lot of the issues with the with the ethics. Like even in the when the nuclear energy or nuclear things happens, like the scientist, he just made the nuclear energy for the good of the people, but the people made the bomb. So the thing, the technology or advancement or everything is having good and bad. Ultimately it just depends on us how we use that. And in my opinion, more than till now, more than 70% people are ethical. They want the things to be good, because we can see it by the society is growing, we are thriving, and we are growing, we are using the things. And means by this time means we can see that we are more ethical, and few people are not using it properly, but yeah, that's fine. So ultimately, we can see that ethical AI use is the main concern of you, and data privacy is fine, transparency, yeah, ethics is, but ethics, you cannot just generalize the ethics. It just depends who is using that. So but yeah, that's fine. So now, just roadmap for integrated circular economy. So first of all, what should we do? We should assess the current systems, like what we are having, and what are the gaps, what we want to do with this. And then we have to use the uh, could you please unmute this? Thank you. So then, based on our assessment and the gaps, then we can develop the AI. It's really like what we want to do first. Like we want to do the waste reduction. We want to use the energy automation, recycling, and then what we can do now, we know what we need and what we have to do. Then we can build a partnership with the companies, with the government and everything, and we can have the pilot projects to see that this is going to be effective or not. Then if this is doing the good for your system, for a society, and for your economy, then you can just scale this and monitor performance, and that's a continuous improvement. So you just do this, recheck it after every 10 years, 5 years, and just track performance and just modify your AI system. So that's not a very big thing to implement the AI. That first of all, the first thing is just you should know that what are your existing things, and what are the gaps, and what you need your system to be. So ultimately, there are, whatever thing you do, there should be the key performance indicators, like we have in the companies and everything. Like we have the KPIs, like how you did in your last year. So there are some parameters on which these performances are checked. So for the AI, what we can use, we have the efficiency matrices, like how much waste uh, have been reduced in by using the AI systems, how much energy we have saved, and how much we have optimized our material resources, and how much we have recovered, what is efficiency, and how much we have reduced our impact on the environment, like how much CO2 have been reduced, and how much we are using as circular material, and how much we are saving the cost, what is the rate of return. So these are the ultimately these are the parameters on which we can check that we have used the AI in our economy, and it is useful or not. So these are the KPIs. So now the future outlook, like so we can have the AI driven innovation trends, like AI powered circular platforms, like we have the digital twins, we can have the biodegradable materials, self repairing textures,
ऑलरेडी
and
आपल्याला 9 वाजता
we can
होमवर्क करायला अजून त्याच्यामध्ये हा
uh,
टाइमपास किती मूर्खपणा आहे.
uh, can you please mute? Thank you. So we can have the AI in developing region, like in India, and we can have for the predictions, like 2030, like more than 60% cities of the all around the world, they are
मला राजू ते
interested to
कपूर
develop the
मला
AI
राजू ते
as
आता
the circular economy.
राजू ते मला ये
So that's a summary, like uh, that's something like, we have we understood what is the role of AI in circular economy. Then we discuss what is the practical benefits and applications of this, like water diffusion and energy efficiency, reduction in carbon emissions, and the reduction in the recovery rates, resource recovery increase. And we discuss the challenges in the data privacy, ethics, and cost barriers, and how the government can be useful in having decisions, and the employment of the deployment of the AI, and the vision that how the AI going to change your future up by 2030. So for the questions and answers, miss, you can scan the QR code, and we can have Miss, I don't think we have too much time, but yeah, just over time. But we can have few questions. Just scan the QR code. You can type your question here, or just you can type your questions in the chat box, and I will be happy to answer.
Thank you, Professor Chetan, for exhaustively discussing the issues. You have very well touched upon all the points of AI, and even the like circular energy, the circular economies, data collection point, the security, the challenges of adoption of AI in all these areas. So I hope the audience must have liked the session, and question and answer are open for all the audience. You may ask. I am giving you the rights to. Okay, the rights are open, so everyone can turn on the microphone and they can ask the question. And
Yeah.
feedback of the session has also been the link has been shared. Would request you to fill the feedback form also. So, any questions from the audience?
Anup sir has raised his hand.
Yes, Anup sir, you may ask the question. Professor Anup Sivanechari, if you have any question.
So.
Okay, one point like Professor Chetan, I would also like to share from my end. Uh,
Mhm.
since I have also done a course on circular economy, and then when I was doing that course, so one more point was there that in the times to come, when circular economy is it would follow, nations has to go for circular economies to minimize the waste. There is also concept of selling of services rather than selling of products. Like as we buy an iPhone, so we buy the iPhone for a certain period of time, say maybe for 5 years, 10 years, depending on the uh, contract of the company. So selling of services is a great way to reduce the e-waste. And
Yeah.
in the government of India is also working on it. And a few months ago, I remember in the newspaper there was a news that they have set a service life for all the products. For example, 10 years of washing machine, and then 9 years for I think fans, electric fans, and then there was 5 years for tablets. So government of India is also working, and that's a great way how we all can work to reduce the e-waste in a circular economy. Every product has a life span, and after that, it is to return to the company so that company can efficiently utilize the waste of that product. So, any thoughts on that, Professor? If you would like.
Yeah, you think the circular economy is the need of need for every country? You know, the means without this means because our country is growing and it's developing country. So and if you want to make the country grow everything, because we are already facing a lot of challenges like uh, you know uh, like wastage and energy is bit challenging, and the demand is ever rising and it's exponentially rising, population increasing. We are already having a lot of extreme events like droughts and floods, and our geography is like that. We have to cover a lot of uh, you know uh, areas which are having very high temperature, low temperature. Sometimes there is flood, sometimes cyclone, sometimes this. So countries, at every instance there is something happening in the country. So I think we are having a very big challenge. So without circular economy, we are not going to optimize the resources. So like if something is higher at a certain city and something is lower at a certain city, so we can and the demand is higher, so we can just shift the thing from there to the high demand cities, and so that the things can rotate and the things can get less wastage and everything. So like you were saying, like in India also, and in a lot of countries, we have the plans like we can just give our mobiles for the recycling, even if it is not working and everything, and they just pay you for something. So here also, we have some plans like if you like the what is there like people in the mobiles, like people just fond of the technology. So like this year they have just got the phone of this model, then next year they are going to have the phone of some different model, just for the they just like the technology, everything. So whatever is going to be with the next model, so either it is going to waste it or they're going to sell it to the the seller. So here what is happening, if you don't like your model, you can have your model on the EMI and everything. So you are paying monthly EMI, and whenever you want to upgrade the model, just give the model back to the company, and just you can have the new model. So like you are just reducing the waste, so that the old model, if someone can have, they can buy it, and is having company insurance and company backing everything and the warranty, and you are having the new model of that. So the thing, this is ultimately the sustainability. So the sustainability comes from the people mindset. Like if ultimately this is, we are the users, the government and everything, they are very small entity, we are the users. So if we don't change our mindset, we don't reduce the wastage and everything, and we don't recycle, so the ultimately whatever the government do, it is not going to help us. So when I was in Roorkee, there was a very and then the mess, hostel mess, there was a very nice poster, and it has had a very big impression on my mind. So there was a poster, like there was a farmer who was sowing the wheat and everything, and it took almost 8 to 10 months from the wheat to get produced and just get to the mills, and convert in the form of flour, and just make your bread and rice and everything. But it just take 1 second for you to just waste it, because you just think how much you want to eat. So, and you just take too much and just you waste it. So the hard work of that farmer of the 8 to 10 months, you are going to waste in only 1 second. So that's the thing, ultimately we are the end users. If we don't think this sustainability, and we have the money, we can buy the things, but ultimately we cannot buy the nature. Nature have limited resources. The earth, soil and everything have, it have the limited amount of fertility and everything, so to produce the things. So ultimately in the circular economy, what you're doing, you are just using the resources and giving back to the nature whatever you have taken. So ultimately you should have something for your future generations. So I really like this idea of circular economy, and if you want to sustain in the growing world and maintain the economy and everything, then we have to uh, just adopt the AI and the principle of circular economy in our governments and everything.
One
So
question
to
from Dhanashri Sahasrabudhe. You have mentioned example of supply chain
Yeah.
management, agriculture production, but how that can we achieved on the basis of previous year's data?
Yeah, so you see, Miss, I told you as an example, like in some years the price of onion is very high, and sometimes price of onion is very low. Like they are just people just farmers just throw them on the road to just show you their anger. Like they are not even getting the price whatever they have invested. So the thing, what is happening, because those guys are not technology sound, but the governments are. So if the government is the production and the demand, there are two things for any economy. So if your production is higher, demand is lower, then price is going to be very less. And if your production is very less and demand is higher, the price is going to be high. So there should be balance between the production and demand. So ultimately, based on historical data of every city or every corner of that, you can know that what is the trend is going to be in the prices. Or the government too is, you see in the every March or April, the government just show data that this year this much is going to be the wheat production in India. This much is going to be the rice production in India. So how to do it? They have the satellite imagery. They just do the land use, land cover mapping, everything. Just see that how many people have sowed the rice or wheat or other kind of produce and everything. So they just estimate the with the help of the agriculture, the farms, everything, that this is going to be estimated production of a certain agricultural products. But the thing, they came to know it after the farmers have invested their money and sowed and everything. So in the AI, you can tell them that this is going to the all over country demand in the next future for the wheat and the rice and other things, and these areas are this regions are really good at having better yield in the wheat. This region have better yield in the rice. This is have better yield in the cotton. These things. So you can ask the farmers of this area to have this much of amount of rice, grow this much amount of rice here, grow this amount of wheat here, this grow this amount of paddy or whatever here, so that ultimately you can have uniform means quantified number amount of prediction of productions of everything. You could utilize the resources. So but for that, our farm need to report their crop with the government. No, it isn't like that. What is happening. So now the farmers in India, they are having the soil card, so they can have their soil get inspected, that how much is their fertility and everything. So what is happening, the government is going to tell them farmers beforehand that okay, this year you guys should means invest your energy or money in harvesting or just sowing this kind of crop. Fine. So ultimately, this is like this. So the people should tell them, okay, in this region, if you sow this kind of crop more, then you are going to have means higher yield, and you're going to have a higher amount of money. Because you should tell them, because in these kind of regions, if you grow, if a lot of people or a lot of farmers are going to have the rice or onion and everything, the price is going to be lower. These farmers know these things, that if they grow the things more, the price is going to be lower. So ultimately, this is the responsibility of the panchayats or the government agencies or everything, to tell them that you have to grow this kind of things here. You have to grow this kind of things here, and ultimately, the it is the responsibility of the government to circulate everything in the market where the demand is higher, where the demand is lower. So it ultimately, and the government cannot do without the help of AI. So, and they can monitor the production and the quality of the crops and everything prime time with the satellites, and they can monitor that okay, this is going to be the annual productions of these things. So means I hope you got some idea how it can be useful.
Definitely, Professor Chetan. Uh, Mukta ji, Mr. or Miss, I'm not sure. Mukta is having some question. So, Mukta ji, can you please post your question? Or you can on your mic and you can ask the question. You can raise your hand. Mukta ji, you can unmute and you can ask your question. Mukta Makhija ji, are you there? Okay. Let's finish this session. Thank you very much. And with small information, I would like to finish this session, because this session is on circular economy. So one little information that I have retrieved when I was joining a course on that. One cup of coffee, it needs 200 liters of water. We generally think that a cup of coffee is only a cup of coffee, but the growing of coffee seeds and then transportation to home and then packaging and all these things, so it needs 200 liter of water, whereas a cup of tea needs 20 liter of water. 1 kg of wheat required 1300 liter of water, and 1 kg of rice needs 3500 liter of water. So when we waste say 100 gram of rice, it means 50 liters of water have been wasted. This is a small information that I would like to share with you all the participants. Thank you so much for being the wonderful audience. Have a sound and wonderful sleep ahead, and we'll meet again tomorrow with new energy and new zeal. Thank you, everyone. You all can leave, please. Thank you, Professor Chetan.
Means guys, you can just scan this QR code here, and it will just can help you connect on the LinkedIn. So you can just get misconnected there and ask for the questions there. So please scan the QR code, and we can just discuss there. So because we are already out of time, more than 15 minutes, I think. And,
if audience want to connect further, and they can connect to Professor Chetan with the QR code given on the screen.
And thank you all for participants, and yeah, ma'am.
Okay, we may finish the session, Professor Chetan. Thank you very much.
Yeah, thank you all. Thank you. Have a good night.
Thank you, ma'am, and thank you all the audience.